Yeah. Well, I want to say this is Halloween, and I want to talk about a little spooky force, quantum entanglement. Remember, Einstein really hated quantum entanglement, and he called it spooky force. So today, since in honor of Halloween, we hope you guys become more entangled in this process. So that's our spooky Halloween thing for the moment. So as we go forward today, again, we really appreciate and thank you for all your input and your presence. People came a long way. We have a room full of world-class experts. We want to make sure we take maximum value in that. So we're going to have the panels this morning. But first, we're going to have Doug Wicks' economic presentation. We heard loud and clear. People are really curious about how does the economics of geological hydrogen, as we know today, look and compare to other sources of energy, other sources of hydrogen. Is it going to be viable enough, cost-effective enough to make a difference? We heard those in many of the questions last day. So we'll start with Doug's presentation. We'll follow by our two panels. But before we do that, we're going to give you an opportunity through Slido to ask any question that you think is appropriate. Any gaps you see that you have questions, any expert that you want to really address a question to. So we'll have about an hour of really answering those Slido questions by whoever in the audience is appropriate to answer those. In the afternoon. This is after lunch. So the two panels will take us through lunch. Doug's speech, talk in the two panels. Followed after lunch, then we'll have this open discussion and of those questions. And then we'll follow that by time for you guys to network. And that will be, and then we'll have a brief closing. Yeah, would you rather have the closing? Let me ask you this, yeah. But the closing, we'll do the closing remarks after the hours or discussion. You're free to go, but you're also free to network. We'll leave the space open and discuss. I think one of the most important, valuable things here is as we look at developing sustainable research, is you guys figure out how you can best do that and how you can partner to do that. We've seen the huge amounts of interdisciplinary research we need. We've seen some huge unanswered questions out there in the science community, but also today's panels will inform us about the kinds of questions that the funders, the regulators need to know, the legislators, all the people that make the land resource management decisions are going to need to know from the science community. So I think it's to be a very useful day. Again, as we started at the base of the pyramid, the fundamental science questions, the fundamental methods of potentially assessing hydrogen, all the way up from the source rocks to the migration pathways, through storage, some storage questions in terms of reservoir seals. And then today we're going more into alternative hydrogen approaches, and then into, again, sort of the regulatory policy regime. And that's kind of the capstone piece of this. And also, we're really interested in looking at the synergies between manufactured hydrogen, hydrogen economy, hydrogen storage, and geologic hydrogen. And your views on that are really important. I'll just give you my personal view right now is that I think it's very synergistic and not in a competition between hydrogen methods. It all fits together in terms of the hydrogen ecosystem that's necessary. But other people may have different views on that, so it's going to be really, really, I think, a healthy question for us to look at.
Quick question.
Okay, so what I want to talk to you about a little bit today is everybody always asks me, what does it cost? You know, that's the number one thing they always say is, this is great stuff. You're talking about good science. What is it going to be? And I want to start a little bit. And by the way, this is where I'm talking about work that was done within DOE. It has to be validated in the field. This is kind of looking at it, the work we're going to see. We did to actually say, where do we need to do work? So the numbers might be off, but we think that the distribution of numbers within the value chain are correct. And they get a pretty good idea and are informing us of saying, where do we need to invest more money for technology development? And pardon me as I wait for the slides to catch up with me. I'm kind of watching it over there and it's popping all over the place. Okay, so And to do this technical evaluation, we looked at, running a techno-economic analysis, or a TEA, to do this and to say, we can, we can understand it. And I could also come back to my leadership in ARPA-E and say, if this works, somebody's going to make money, which is a really important thing. So the first thing to look at is, we've discussed it, that there was these great models out there of how hydrogen is going to be part of the energy transition. And this is work that came out of the IEA. And by the way, I will tell you my personal belief, this is stupid. It's not going to happen. We're not going to see hydrogen have this effects with the way that they were planning to it. We saw it yesterday from Jeff talking about, or 2 days ago, Jeff talking about blue hydrogen and green hydrogen. This won't happen at all at current systems. And the challenges we have, if you look at this, roughly depending on the price of natural gas is going to impact this, as do many other things to grid. If you take a look at it, that steam methane reforming gives you about $1.15 a kilo. And if we do slap CCS on the end of this, to capture all the carbon, not all the carbon, we only capture about 80% of the carbon. That's what this model shows. So we still have pretty intense carbon emissions, but it brings it up to about $1.65. If you want to bring it down to zero emissions and capture 100% of the carbon dioxide formed, it actually goes exponential, and the price at zero carbon footprint stuff from SMR under current technology, somebody might be talking about different technologies, it would put you up in also in the $5 to $6 range for stuff. If you notice, these are pretty far off of the $1 a kilo DOE activities or Earthshot. And there's challenges, and it's even changing. You look at the price changes that have taken place. When we started this whole exercise within DOE, the assumption was that green hydrogen from electrolysis was about $3 a kilo. And coming at this, and the expectation was we were going to drive this number down. When you do the analysis over the last couple of years, the price went up. This is not a good indication. So the more work we do, the more expensive it gets. This is not the way to go. And you can take a look at it, reports are coming out that they're saying by 2030, it was going to be $3 to $5. They're now coming out and saying it's going to be higher than that. We're not making the investments because the prices aren't coming in, as evidenced by Fortescue, probably the largest industrial investor in green hydrogen, pulled the plug on their systems this year, just a short time ago. There's been dozens of major pullbacks in the green hydrogen space. So clearly, if we want hydrogen, the market is beginning to speak to say, this is not going to work. So what did we do? I mean, we started looking at geologic hydrogen in this, and we did a back of the envelope calculation. We basically went out and said, what's a good equivalent? And we said, well, let's take the worst case in Marcellus tight gas. So this is looking at methane production from Pennsylvania. There was a great report out there where somebody did an in-depth financial analysis of production cost of natural gas in Pennsylvania. Really gory detail, and we went out and picked the worst ones out of it and said, we are going to, on a volume basis, not an energy basis or anything else, on a volume basis, say we can be as effective as natural gas, with all the stimulation effects and fracking and everything else built into this. And, we came back on a volume basis, natural gas, coming out, in 1 million cubic feet from, again, tight gas in the Marcellus, somewhere between $1 and $4 a million cubic feet. And then came back and, because we can't talk in numbers that make sense to the people in the natural gas industry, we had to bring it back into kilograms and brought it back in and say that those numbers correspond between 6 cents and 24 cents a kilogram on a weight basis. But if we plug hydrogen in there, we come up with this number that's between 44 cents and $1.78. And this was a back of the envelope calculation we did years ago. And that was enough to tell our bosses, somebody might make money, $1 a kilo is in that target. So let's go forward. So now that we have programs in the area, we need a little bit more refinement, and we need to say, where is this cost going to come from in geologic hydrogen? So we went back into the map I showed you yesterday, and this is where it came out of, was looking at all the costs of exploration, bringing it in. All the drilling has to be in there, the well completion, the stimulation if required, in the system to come back and say, how much is this going to cost? Everything above ground, we ignored. This was outside. There was enough people doing TEAs on how much it costs to move hydrogen around. We didn't have to do this. And so we went into this system and said, and gave it to a really young student with lots of energy and lots of experience in the area, and said, tell us, go in gory detail and talk to everybody you need to do. Don't take it no for an answer from anybody. And begin to look at it. And we said we want to look at a couple of things. We want to look at, as I mentioned yesterday, this natural hydrogen extraction. Jeff is going to find us, the Bakken field of hydrogen, and we're going to drill down to it and start sucking the stuff out. From that, so it's trapped down there, and it gives us one model. And then the other model is saying we have to stimulate this, that we're going to have to do similar to tight oil, tight gas or tight oil. We're going to have to do something to drive the system. And again, coming back to this slide again, looking at we need to understand what we're going to be stimulating it. How do we drive this? We have to be able to sustain the reaction over time, and this gets reflected in the TEA, and then accelerating the reaction, taking data from our existing projects and bringing this back into the model to say, what is it going to look like? So we have this information that's developing, and we looked at 4 cases. And again, this I will emphasize, this is for demonstration and illustration only. This is me. Do not go out and try to raise money off of these numbers. This is me trying to find the pain points where I need to invest money in. So we have several systems. The natural well, we're just going to drill down to it. We're going to do over and under. So we're going to drill down beneath this natural accumulation and stimulate it to come up. We're going to look at side-by-side systems. This is what you see in enhanced geothermal. And then we're going to do a hub and spoke model where we're going to drill one hole in the middle for injection and then have 4 collection holes around the outside for this. These are all conventional models that are used in oil and gas. So then we went out, and this kid, I got to really admire him. He went out and found all the experts in the field and said, give me what the numbers are. And I don't want to go over all these numbers. I just want to let you know we went in depth. So we looked at the cost of aerial surveys to go out for exploration. Then we found aerial go in and do seismic, do exploratory drilling to come into this, and then come back and leasing and permitting. So we actually factored in the cost of leasing and permitting into these numbers you're going to see. And it's impressive what we were able to do. We spent a lot of time looking at drilling costs. So he went out and talked with the world's experts on drilling. So we went to the oil field services companies and to the oil companies and said, tell us what it costs to drill. For some reason, they told this kid what it cost to drill. So we got really good numbers about what we would have to do going down. Really have the input and looking at depth versus costs and time and everything else to really begin to develop a model out of this. It's very important to have a lot of detail in this. Remember, our initial number was, I pulled out an envelope and went, and came up with a number. So this is a person who came back in, and this is all in costs. We then went through all the cost of completion of doing this. And this is putting in, how much it costs to finish the well. In gory detail. I mean, consumable. I mean, I'm looking at this guy. What are you doing? I was very impressed, by the way. He's back at Stanford now. But he was able to go through and find ranges of costs for the different systems. We brought in technology from Sandia, or estimate modeling from Sandia and NREL in terms of enhanced geothermal fracking. So we know what the cost differences were this. We upgraded the materials that are going to be used in completion for hydrogen and really did this very much in depth. There's another whole section that we went into on modeling fracking and modeling of reactions, which I'm not going to show because that stuff is really, that's my secret sauce. So you can run all these numbers and they don't make sense unless you have the secret sauce we have, which is all proprietary so far. But we went through this. We even went through on the stimulation side and said, we're going to do similar to what they did in the oil fields, where you go out and you do your hydraulic fracturing, your production decays, and then you go back out, drill another hole, frack on another angle, decays, put it back up, go back down. Very typical systems you're going to find in tight gas for this. So the stimulation ones have these costs in them. These are the numbers. We went through this, and it's really coming back to say, that just direct, and by the way, we looked at different depths, and so this is 1 kilometer and 3 kilometers, to come back in and say, what's going to be the impact? So this is not just a single number, and it's looking at it and saying we're getting ranges, based on our confidence, and, that come from that 50 cent a kilo range. If we do find it. And as we move off into the stimulation, the different methods, and again, this is going to help guide us to say what types of methods of stimulation do we need to do? What are the expectations of this as we accelerate it? We want to have these numbers because this is going to tell us what kind of projects we need to fund. We need the sensitivity. So these numbers might be, what was the comment yesterday that 12 months from now, half of what we know is not going to be right. And 12 months from now, this might be wrong. I've already had several in the industry tell me, no, my numbers are too high. They're looking at it saying, oh, we can do better than that. And this is from people who do oil and gas for a living. This is not my academic performers for this. And so what this tells us, though, and the message here is, though these aren't exactly accurate, there's going to be some movement in it. It does say we are well below the cost of green hydrogen, and we're competitive with SMR, outright in SMR with carbon capture. We have the potential to be there. So again, these numbers are to be taken with a grain of salt, but they do tell us there's something there. And this modeling, again, is continuing. We're continuing to develop it. There's a whole bunch of things we need to begin to inform it with our teams. A lot of it comes down to production rates, regeneration rates out of the system. These are all things that we're trying to answer, out of these processes. But again, the analysis for us tells us where to invest. And that's the kind of message I want to bring along to say, it's not a pipe dream that this could work, right? Just have to find the people who can do it right. I think this presentation is going to be shared, so don't take too many pictures. So thank you. And by the way, if you ever want to have fun, you can fly to Oman, and you can actually go to places and bend over and capture in a cup 100% pure hydrogen just bubbling out of the ground. And you look at it and it's amazing stuff, all formed at low temperature, low pressures. so that we can do this. So it's neat stuff. With that. Do I take questions now or do I? The major variability is going to come, well, first of all, what kind of rig you're looking at, big, small, and everything else. I mean, there are ranges behind these. I'm glad somebody went out and picked out a number out of there. It's going to depend. I mean, the real big difference depends where it is, and that's going to be your mobilization, demobilization, how many holes you're going to drill, come out of it. We did look at a range of rigs, and those are the averages. Yes, Alexis. The question is, can we do stimulation in thin surface bodies? I don't know. I'm a program director. I don't have the answers. If I had the answers, I wouldn't be working at ARPA-E. I'd be out doing them. That's for the teams to come up with, to say, how do we stimulate materials at different temperatures and different conditions? And then from the engineering side to say, how do we capture it? Yeah, the numbers we had when we looked at the exploration cost assume a lot of failures. And bringing in a lot of failures brings it up for a natural accumulation to 60% of the capital needed to develop that site is exploration. That's assuming you've got a lot of failures and investors who have the tolerance to let you have those failures such that you can amortize those exploration costs. It's 60%, which is the clear message to us. That's a pain point. Yes, Allegra? Yeah. We are paying the student who did this to still work on it when he's back at Stanford, and he's going to get himself a refereed publication out of this. Yeah, so the decay curves, I mean, the outright top production number came from secret sauce. The decay, we haven't done enough research on yet. We just took a very typical gas field number. When you look at a gas field, what they're going to do is they're going to put in a central site. They're going to go out, drill a hole, frack it, let it decay, pull it up, drill another hole, frack that, and use the same platform. And that's the model we used. Yeah, we just assumed that a 5-year decay. If my research teams come up with much better ways to increase the penetration of the reaction into the rock, and that could be 7 years, which would have a huge impact on cost. Yeah, I mean, I can't remember the exact number. I want to say that we assumed 1 of 8 that get to the point of drilling would actually be successful. And you've gotten rid of a whole bunch of stuff there doing the earlier work. Any other questions?
If you looked at the success or lack of success in government-sponsored drilling programs in NPRA, where for 30 years we paid people not to find oil, drill for it anyway.
We have looked at it, and some of it's actually quite interesting to us because we're looking at it saying they might have found hydrogen and not told us. So we're actually going back and looking at some of the stuff that the government paid for, especially the offshore stuff. I mean, they drilled the whole East Coast and found nothing, which was good because we have a lot of data now that tells us, that there might be hydrogen there. We'll have to see. Government drilling, I'd much rather have money and give it to somebody who knows where to drill. Well, no, so 1 of 8 exploration wells is going to be, One of 8 sites. I mean, actually, if you look at the exploration numbers, we have multiple wells drilled at an exploration area, and we assume that 1 of 8 campaigns is going to be successful. So we've drilled multiple holes at the same location, and we named it's going to take 8 locations to get one that works. Yeah, and then once you're producing, we assume at that point you know what you have. We've looked at that, and in terms of of my needs for directing the research, it doesn't really add much. Right now, we need the basic science to drive those decisions, and that if some of our assumptions are correct, hydrogen's everywhere. It's just a matter of how deep you have to drill. We don't know what's down there, but I mean, if you'll hear a lot of discussions. You just drill to the basement and you figure out how to collect the hydrogen there, release it, which totally upsets the transportation costs if the models are correct. Right now, we're looking for, again, what my teams have to do to change it. Yep. Oh, we looked at 3 kilometers and 5 kilometers. I think we've also modeled, yeah, I mean, our explorers at 1 and 3, I can't remember whatever the numbers were on the slide. And I know we have modeled 5 from the different methods, and we've taken the standard method of drill down 5 kilometers, run 15,000, 20,000 feet horizontal for these systems. No, that's for the stimulated, have the over and unders have long distances to them. Yep.
Here we go. Okay, I'm not going to repeat myself. Could we get the presenters and Gwen up here for the next session, which is session 9? So J.R. Wilcox, Dave Clarke, Mead, Treadwell, and Tim Johnson. If you guys could come on up, that'd be great. So this session, we're going to take a look at some Alaska-related projects that are actually in process, I guess you would say, with some real work that's been done. And our moderator for this session, which is perfect for this session, is Gwen Holdmann. And I've known Gwen for a long time. First met her back in the mid-90s when she was just starting grad school. And she was a dog musher. And many of you might not know this, but Gwen competed in the Iditarod and the Yukon Quest dog sled races, which are both 1,000-mile races. So she's got some real metal inside her there. Those are hardcore events. She has graduate degrees in, let me get this straight here, physics, engineering, and energy policy. And when I met her, she was a graduate student in physics, as I remember. Before joining the university, she spent some time as a lead engineer on the only geothermal power plant in Alaska, where she worked on not only the power generation, but coordinating the geophysical work and developing the resource. She's led similar exploration efforts at other geothermal sites in Alaska, notably at Pilgrim Hot Springs on the Seward Peninsula. Gwen is the founding director of the Alaska Center for Energy and Power, and kind of a dynamo within the university in terms of research work that's going on. And so I think Gwen is the perfect person to moderate this panel. So Gwen, thank you.
Thank you, Steve. It's been a real pleasure to be listening in on some of the conversations here. Steve alluded to my background in geothermal, and the place I first heard of geologic hydrogen, I remember I was in Iceland almost a year ago at an international geothermal conference there. And I've been dabbling in the geothermal space and going to these conferences in geothermal for a very long time. And especially early in my career, I noticed like there's a lot of kind of white-haired, silver-haired gentlemen in the room, and I'm at this conference, and there's like a ton of young people. There's a ton of energy, and it was really interesting to me. And part of the reason I was there was I'm interested in super hot geothermal, but there was also this kind of chatter about this geologic hydrogen, and I'm like, what is that? Because I've been always a little bit of a hydrogen skeptic, a little bit. In my career as more of like a engineering side, power generation side. And so I started to kind of learn about this. I heard about it there. I kind of started tugging on this thread. I came across a lot of what Jeff Ellis has, talked about previously. I'm super glad that he was able to join us here. And ultimately, I actually put together, I have a podcast called Closing the Gap, and I put together this whole series on hydrogen, talking about everything about how we've used it in the past and how hydrogen is a major component of like town gas that we used to use. And so, there's like kind of this interesting history. But while I was in Iceland, one of the things for the podcast I pulled out was this quote from a 1910 paper. And I'm going to read this to you guys because I know all of us, here have some different levels of like skepticism or not sure where this all fits in. Like where are we going to see ourselves heading with this, this concept of geologic hydrogen in the next 10 years. So I'm going to share this with you to give us a little bit of a broader perspective. So this is from a 1910 paper, and your job is to tell me what technology they're talking about, okay? Engineers in our era create many peculiar inventions. This is a translation, so it's a little funky language. Often these inventions are so astonishing that they seem like sheer fabrications. However, people have frequently encountered situations where what was deemed utterly impossible has proven to be achievable. This prompts a cautious approach to dismissing the feasibility of any idea, no matter how implausible it may initially appear. What's the technology? The airplane, sure, the aeroplane, sorry. I mean, there's a million technologies that we can think of that would sort of fit this, right? But this is in a newspaper in Iceland in 1910. So that might help. What technology are they talking about? Go ahead. Nuclear. No, they're not. Okay, what kind of geothermal? What kind of geothermal? Okay, who's been to Iceland? Okay, yeah, who said that? Yes, so geothermal district heating. So at that time, Iceland was in the process of figuring out, could we actually heat our homes with geothermal energy? And they'd had a couple folks that kind of experimented with it and dabbled with it and like hooked up, their house to some, upstream, like little geothermal, hot springs or something like that. But they heard that Boise, Idaho was actually heating their entire downtown using geothermal. And they were like, is that possible? Could that really happen? Could we do that here? And so they wound up writing a letter to the mayor of Boise, and this created this like back and forth across the Atlantic. And ultimately, today they are the experts. And if you go to Iceland, this idea of geothermal district heating is just a given, right? Like of course they did that. It totally makes sense. They obviously have that resource. But if we put ourselves back 100 years ago, this was not known to be possible, right? And so I think it's really important for skeptics, and I'm saying this to myself, really. I can be a skeptic about hydrogen, to just remember that there are a lot of things that over time society has been skeptical of that have actually come to become very mainstream. And so I think this is a really exciting time when we're looking at geologic hydrogen, because we don't know yet. We are not sure what this looks like and how this fits into this broader decarbonization of our energy supply. So with that, I do kind of want to, I'm very excited about this panel, and I was kind of thinking about this a little bit. Timothy, I have not met you. We are going to adopt you as like an honorary Alaskan for this panel, because what I want to say is that these are, if there is a place where this kind of thing can happen, Alaskans are incredibly entrepreneurial. They're incredibly innovative, and they're incredibly willing to think broadly and outside of the box. And this panel represents those minds. That's why we're also going to adopt you here, Timothy. So, so I'm just going to quickly introduce the four panelists. I'm going to turn it over to JR to kick us off. But JR, you're the founder and the CEO of Oh, Alyeschem. Yeah. Okay. Which you always see these written down and then you don't have to say them out loud. And that's one of the many companies that you've been involved with, founding over the past decades. You spent most of your career in the oil and gas industry, initially as an environmental scientist, and then working on various roles with BP, Forest Oil, and Pacific Energy, and eventually helping found Cook Inlet Energy in 2009. You have a BS in chemistry and a master's in environmental chemistry from UAF. And the coolest thing about you is that, and I just love this fact, is that your great-grandfather, Howard Wilcox, was the first dean of the College of Engineering and Mines. And when your daughter, Sophia, graduates, she would be the 6th generation UAF graduate. Is she still studying psychology? Fifth generation. She's a junior. I'm so glad that we were able to drag her here to UAF. I think that's just such a cool story.
Thank you personally.
I was like, he's like, can you get my daughter, can you talk her into coming to, I'm like, yes, let's figure this out. I'm like, she has to come to UAF. So, so that was great. Okay, David Clarke, you're also a chemical engineer by training. You spent 36 years working for BP all around the world, but with a focus on developing major projects in deep water and Arctic regions. In 2022, you formed Alaska Marine Power, AMP, with your partner Simon Harrison to develop large-scale renewable energy, such as offshore wind and Cook Inlet, which would support an e-fuels industry on the Kenai Peninsula for the export market. And then Mead, you don't need an introduction for the Alaskans in the room here. So I don't think you need much of an introduction at all, but you are the former Alaska Lieutenant Governor. Mead is also the former U.S. Arctic Research Commission Chair. He's a serial entrepreneur, which is very true for him. He's one of the more innovative people that I know and has been involved in several companies and nonprofits focused on Arctic investment and science. And you're in the role here today, you're the chairman and CEO of Clarke LNG, aiming to export North Slope natural gas and perhaps hydrogen byproducts directly by ice-strengthened tanker to markets in Asia. So my little thing about Mead is I'm very proud of the fact that we were able to award you an honorary doctorate earlier this year, actually, it was still this year. And if there's anyone that I think is a lifelong learner and deserves that, I'm really pleased that UAF was able to recognize you in that way. All right, so Timothy, you are the president and CEO of Graphite Creek Copper. It's a Canadian, I did a little research because we haven't met. So it's a Canadian mineral exploration company. Is it based in the Yukon or you're headquartered in Vancouver?
We're headquartered in Vancouver.
Vancouver.
We have a project in the
Gotcha. Okay. He has over 30 years of experience in mineral exploration industry, ranging from grassroots prospecting to consulting company operations and public company management. So we have a diverse panel here. All of you are innovators in your own right. And I would like to start by turning it over to JR. I think we'll just go ahead and each of you will give a brief presentation. And then if we have time, we'll do Q&A, through the app thing. So be thinking about your questions while we're going along. Otherwise, I'll get to monopolize all the questions, which I would not mind. So go ahead, JR. We'll turn over to you.
Thank you. Okay.
Do you want to just stay there or do you want to come up here?
Whichever's,
All right. I'm just going to give that to you. Okay.
Okay. No, testing. So I'm told I have 10 minutes here, so I'm going to have to talk fast. So thank you very much, Gwen, and thank you so much, Mark, for the invitation. It's a great honor to be here and be able to share a little bit about this project and what I've learned along the way that might be useful for thinking about these larger questions of geologic hydrogen. My company, Alyeschem, is developing a chemical plant on the North Slope. We view the North Slope as being a tremendous multi-generational asset and figuring out how we continue to use that in the future hinges on some key questions. How do we monetize the gas? How do we lower operating costs? How do we increase the resource base? How do we adapt to fuel transition questions? And chemistry winds up being at the heart of all of these things. We're developing a petrochemical site in central Prudhoe Bay. The focus right now is methanol and hydrogen. The hydrogen would be used to convert the kind of high sulfur diesel that's currently produced on the North Slope into ultra low sulfur diesel, which is what's needed in order to operate vehicles and drill rigs and such. Those are the top two things that get trucked to the North Slope. We'd like to make them there out of the stuff that's on the North Slope instead of needing to haul it up. You can see this is what the current methanol supply chain looks like. We've been moving it thousands and thousands of miles to the North Slope for over 40 years, and it's the simplest thing to make out of natural gas. This is our plant site. If you're familiar with Prudhoe Bay, that's Flow Station 3 at the top. That's a 15-acre pad. We have that on a state lease. We owned the gravel. We sold half of it to Harvest LNG so that they could build the plant that's going to be shipping liquefied natural gas to Fairbanks. And then we'll be sharing that common 1,000-foot pipeline to tie into the field fuel gas system on the North Slope. This lease can, and the pad can obviously be expanded over time in order to accommodate different uses or expansions as this site develops. This is the current view of the 3D model of the plant. There are tanks for bringing high sulfur diesel in, for storing ultra low sulfur diesel that would be shipped out, and for storing methanol that would be exported. There's a truck loading rack, and there's the production facility. The tall thing in the back is the steam methane reformer. That's taking natural gas from the Prudhoe field fuel gas system and splitting it into carbon monoxide, CO2, and hydrogen. That then passes through reactors in order to combine that into methanol, which is CH3OH. Because of the balance of how those different molecules work out, we wind up with an excess of hydrogen. So that hydrogen will then be going through purified and then run through a reactor with the high sulfur diesel. It grabs the sulfur and turns into H2S. That then gets separated and turned into elemental sulfur. There are various different ways to make methanol. One of there's a lot to be said for methanol, which we'll get into, but I think of interest, it's the densest form you can put hydrogen in. It's stable at atmospheric temperature and pressure. And it can be used as a fuel. It can be used as a chemical precursor. It's a very useful chemical. There's a Nobel laureate, George Olah, who wrote a book called The Methanol Economy, which actually talks about how you could move from a fossil fuel-based economy to a methanol-based economy because it's a great energy carrier, and you can make it from so many different things. Natural gas is, of course, the easiest thing to make it from right now. You can also make it from CO2 and hydrogen. So right here, I've just shown 4 different ways to make methanol chemically. Because of the high CO2 content in Prudhoe Bay field fuel gas, Alyeschem will be somewhere between the top 2 mechanisms. So you can take just pure methane and water, and you can react it into balanced one methanol molecule, one hydrogen molecule. You can also take CO2 into the process, and then you're able to displace some of that water, but you're producing less hydrogen. You can see that that's more energetically favored, but both of those take a little bit of energy to have happen. But e-methanol is where we're actually taking water and CO2, and the net reaction for that is that you're creating methanol plus a little bit of oxygen. And you'll notice that has an extremely high energy cost. But if you have a lot of cheap power and you've got a CO2 source, that might make sense. If you have geologic hydrogen on site, you can take 3 of those hydrogens to 1 molecule of CO2, and you can create water and methanol. And that one is the only process up there which is energetically favorable. So that's green methanol. So geologic hydrogen would be an excellent source for methanol production because you don't have to stick any more energy into it to make it happen. And that then has converted the hydrogen into a transportable liquid fuel. Hydrogen monetization, of course, is being talked about a lot at this conference, as it should. If there's a robust market for hydrogen, there will be a lot of funding coming into how do you get that hydrogen to market. If there's no real market for it, then you're kind of pushing on a noodle. It's very difficult to move hydrogen at distance by truck or ship. So your options are basically you can use it on site. You can use it for heat, power, making chemicals. You can move it by pipeline. If utilities start getting okay with it being put in natural gas networks, obviously those could be leveraged, or you're stuck trying to find a dedicated hydrogen pipeline network. The last option is that you convert it to some kind of a stable carrier. Methanol and ammonia are not just useful as products in their own right, but they can also be used to transport hydrogen, and ultimately it could be converted back to hydrogen again. I know there's also work being done in metal hydrides and absorption and other ways to try and make that hydrogen more shippable. But as mentioned, methanol does have the best hydrogen density per mole of any other thing you can do with it. Looked at from another direction, there aren't a lot of great alternatives to fossil fuels, but alcohols are really one of them. You use methanol for racing. It burns in an engine. From the beginning of internal combustion engines, alcohols have always been used. It was really fossil fuels that kind of pushed alcohols out, but for cost reasons back during the initial development of the engine. So there's two kinds of technologies really that you can look at for engines that burn methanol. There are engines which are predominantly fueled by methanol, like up to 97% methanol. These are becoming fairly standard in new shipbuilding due to EU standards. There's a lot of advantages to them, but due to EPA engine certification rules, it's very difficult to import them and operate them in the United States, even though the emissions are significantly better. You can also do instead of dual fuel, you can do a mixed fuel, and you can convert existing engines. So this is something that we at Alyeschem are very interested in right now. Door Motors is an Israeli company that we've been talking with, and they have these kits that can move to the outside of an existing diesel engine and replace up to 80% of that diesel with methanol. And in the process, they can lower operating costs and they can improve emissions. The biggest challenge here is trying to figure out how this can be done legally, which is going to require a fair amount of testing and hand-holding with EPA. So yeah, in conclusion, Alyeschem is going to be developing this plant. We really believe that this site could be used as a great future platform for innovation. We'll have available heat, power, gas of various kinds, loading racks, tanks. Through work with the Department of Natural Resources, we can expand the methods that site can be used for. Having it be a mining land water lease instead of an oil and gas lease, either surface or subsurface, is really useful for being able to do lots of different things legally. And we're very interested in partnering with people on research and development. I know we've got 2 questions coming up, and yeah, my recommendations on both of them are that developing geologic and manufactured hydrogen in Alaska both will be leveraged by supporting any kind of market development for hydrogen and hydrogen derivatives, and that being able to test and demonstrate mixed or alternative fuel engines that can utilize the hydrogen carriers is a good part of that. Another one, it seems to me, would be trying to figure out if you can blend hydrogen into existing gas networks. So hopefully I made it close there, and thank you.
Good morning, everyone. I'm David Clarke, the Engineering Director of Alaska Marine Power. I'd like to start off this morning by giving you an overview of the large renewable energy potential in Alaska, and then cover hydrogen generation and storage and how that could possibly open up a world-scale e-fuels industry in Alaska. This is a map that was produced by NREL for BOEM. It gives the technical power potential in Alaska, which is an enormous 3,800 gigawatts. Like maybe with geological hydrogen, most of this renewable energy potential is in remote areas and without infrastructure. And so only about maybe 2% is likely to be viable, at least in the short term. So we've really been focusing on the 95 gigawatts that's in the Cook Inlet. That's about 2/3 wind power, and the other third is tidal. Focusing in on the Cook Inlet, you can see on the map on the right that the best of the best wind is actually in the lower Cook Inlet between Mount Augustine and the Barren Islands. And we reckon there's about 10 gigawatts at least in that red rectangle. The reason the wind is such high quality there is due to the topography, with the high mountains focusing the wind into that rectangle from all four directions. And then they will be looking at an HVDC line, tieback line to Nikiski. NREL did a technical economic analysis for a shallow water location, which is next to Augustine, and a deeper water location, which is in the east next to the Barren Islands. This actually wind resource is in the top 1% of all US offshore wind resources. So it's extremely high quality. And you can see from the graph on the top left that the shallow water location is literally off the scale in terms of wind quality in meters per second average over throughout the year. But do note in the bottom graph that the wind does drop off significantly during the summer months. So what are we going to do with this power? We need at least 1 gigawatt to achieve economies of scale. This is actually this is about double what the rail belt actually uses. So we're finding ourselves very similar to what the situation the Cook Inlet was in the 1960s, where they were drilling for oil. They found a huge amount of natural gas, and the local market was really minuscule. So they had to create a market for that natural gas. And at Nikiski, they built the US's first LNG plant, and at what was at the time a world-scale ammonia urea plant. So what can we do with the power? Well, we have to create the power. So the most obvious one is to produce hydrogen through electrolysis. That could then be supplied to the ammonia plant, which is currently mothballed, to produce green ammonia for the export market. Then if we can get a source of carbon, and the most likely source of carbon would be CO2 imports, as Commissioner Boyle discussed yesterday from Japan, that would allow us to produce a wide range of e-fuels for the export and the local market. The big challenge that we have is that the wind is intermittent, and most chemical plants, for operational and financial reasons, want to operate 24/7, 365 days a year. So it's absolutely essential that we're able to store large volumes of hydrogen, and we're talking about tens of thousands of tons, so that we can supply a constant feedstock stream. If we get this infrastructure in place, then there are significant local benefits, but the local benefits really are the icing on the cake. We need to create the export market to justify building all this infrastructure. So how do you store large volumes of hydrogen? So on this chart, we've got time on the y-axis and energy storage on the x-axis. And note that these are logarithmic scales. To give you an idea of what 1 terawatt hour is equivalent to, the total annual generation capacity in the rail belt is around 5 terawatt hours. So currently, hydrogen is stored in salt caverns. That is not an option in Alaska because we don't have salt. To store the hydrogen above ground would just be phenomenally expensive. So we're looking at the emerging technology of storing hydrogen in the depleted gas reservoir. So the Shasta group of national labs, 4 national labs, completed a very, very comprehensive study back in April 2022. That was followed up a year later by a technical economic analysis comparing hydrogen storage in caverns and in depleted gas reservoirs. This is a schematic from that later report. You can see how, on the schematic on the right where 2 salt caverns have been created out of a salt dome, and on the left you have a depleted gas reservoir. The bar chart on the left shows the relative costs. The surface costs for the 2 systems are practically identical, but for the salt cavern, there's a significant expense for actually creating the salt cavern. So in theory, if you want to double the volume with reservoir storage, you just pick a bigger reservoir, whereas you're going to double the cost of creating the caverns. This is a map of the US. In the gold shows the locations where there are salt deposits. You can see that the Gulf Coast is well served, as is the Midwest and also the Northeast. There's a dearth of salt deposits in the Western US and absolutely none in Alaska. So at the beginning of last year, we approached the Shasta team and said, we've got about over 90 hydrocarbon pools in the Cook Inlet, but we really don't know where to start. We haven't got a clue how we would actually high grade those reservoirs to see which ones are most suitable for hydrogen storage. And they agreed to do a case study of using Alaska. One of the recommendations of the first report was that they needed to put together guidelines for project developers to help them select the reservoir. So the first screen that they did was actually on storage volumes. The bubbles in the map represent the hydrogen working gas energy storage capacity in terawatt hours. And actually most of the reservoirs, particularly the ones offshore, are just really too big. Storing hydrogen in them would be like storing a needle in a haystack. So they actually found that there was about 29 hydrocarbon pools that met the theoretical hydrogen storage demand. And 48 pools in total are currently unused. Then they did a physical and chemical suitability screen. On the left, you can see where they looked at temperatures, pressures, porosities, permeabilities, and oil saturations. And there are actually in most of these fields a total of 5 stacked horizons, and they identified the characteristics of each of those. And because hydrogen is non-native to the reservoir, it's very important to look at the mineralogy, and that's the second screen that they did. And as a result of that, they came up with a potentially favorable reservoirs. And so basically they narrowed that down to 7 out of the 92 pools. And very fortunately, those reservoir pools are all onshore, and they're all in the vicinity of Nikiski. So the next steps will be characterization and development. As a result of that work, we produced a paper which has been recently published in the Journal of Applied Energy, and that's available online. Looking at Nikiski today, it's an oil and gas hub. It's got underground natural storage reservoirs. It's a deep water report. There's a refinery in the foreground, the Marathon refinery, and in the background next on the coast, you can see the mothballed LNG and ammonia plants. On the map on the right, you can see where Nikiski is located. The reservoir suitable for CO2 are offshore, and you can see that in purple is where the 4 natural gas storage reservoirs are. This is our vision for Nikiski in the future. You have renewable power coming in from the Lower Cook Inlet. That allows you to produce hydrogen. Got hydrogen storage reservoirs just to the south, and that allows you to produce ammonia. If there's CO2 storage in the offshore reservoirs, then we can produce a wide range of e-fuels, either for export, and there's an existing fuel line running up to Anchorage Airport. This is what the storage facility would look like. This is the Singsa natural gas storage facility at Kenai, and we think the hydrogen storage reservoir would look very, very similar. This is what it looks like in cross-section, showing 2 of the stacked reservoirs. An e-fuels plant typically requires about 2 gigawatts of power. So given our 2/3 capacity factor, we would install 3 gigawatts of power. When we're at maximum power, we actually send 2/3 of the hydrogen directly to the e-fuels plant and put the excess 1/3 into storage. And then as the wind drops below 2 gigawatts, we'd actually pull hydrogen out of storage. But no matter how good the science is, and it is very good, it's very difficult to get investors to come in and spend billions of dollars on all this infrastructure until we actually go out and demonstrate that it works, preferably in the reservoirs that you're ultimately going to use for storage. So we think it's very important to do a pilot, and the main objective of that is to measure hydrogen preservation. This is a potential way forward, mapping out. We've done the science, and Shasta's team have spent about $7 million to date, and they've also completed what we're calling phase 1, which is the resource characterization in the Cook Inlet. Next steps would be to do the project planning and then move on to doing a pilot. We reckon all that would take about 5 years and cost somewhere between $30 and $40 million. This is the last slide that Jeff Ellis put up on his talk the other night, looking at the hydrogen systems analogous to petroleum systems. And really the question for the room is, if we were to do a pilot for hydrogen storage, what learnings could we also how could we transfer the learnings from that to assess hydrogen storage and preservation of geological hydrogen? And finally, we think that Alaska is not just the last frontier, it's the best frontier for wind power, hydrogen storage, green fuels, and potentially geological hydrogen. Thank you very much.
So Gwen, you were introduced as a dynamo. I think if we just could figure out how to harness your energy, we wouldn't have to do any of all this. Thank you very much for your introduction. Yeah, but by the way, if there's any conflict of interest on this panel, is that she did give us our dog, Wiley Coyote. And Wiley is doing fine so far as I know. She was pretending she was a cat just the other day. So the title of my talk is Alaska as a Hydrogen Superpower. And you might have noticed that David Clarke's name is on a second presentation here. David and I got together asking ourselves the question on trying to commercialize North Slope gas. Why weren't we thinking about doing direct export via the Arctic Ocean the same way the Russians have? The Russians have been shipping LNG from Yamal, which is practically Norway, all the way to East Asia now since December of 2017. And we're much closer. And so the question is, what could we do there? And I really got three fast messages. Sorry for the fine print, which is one, to explain our base case on direct LNG export to solve the riddle of North Slope gas commercialization. Second, what we've been asked to do by potential Japanese customers, the Japanese government, which is to look at abatement policies, possibly to convert gas to ammonia, possibly to bring carbon dioxide back, as David discussed, and possibly even direct hydrogen export. And then third, I wanted to make the point to this conference that geologic hydrogen will, if economic, it will roll into a growing and competitive market pioneered by natural gas. We're really in the BTU business, no matter what you're talking about. And where do we clear in the marketplace, whether it's hydrogen that comes from natural gas, whether it's hydrogen that comes directly from the ground that's clean, whether it's some of the other processes, and we'll talk about that. But the other thing I just want to say is, for me as a lifelong learner, it's been a real pleasure to be at this conference. The first time I dealt with geologic hydrogen was as part of a NASA working group in the early 80s. And I helped publish a paper with the head of Johnson Space Center's Planetary Institute on mining the moon for rocket fuel. And at that point, we knew we could center rocks and get about as much oxygen as we needed. What we didn't know, and this kind of proves what Dr. Wicks was saying, that everything we know today is wrong 6 months later. What we thought was our only source of hydrogen was the deposition of hydrogen molecules by solar wind. And we had all sorts of crazy ways to collect the hydrogen then. And the idea of water on the moon was just kind of a crackpot dream. We've since pretty much confirmed that there's water on the moon. There's a race now between several countries to mine the moon for water for rocket fuel. And if you need an example of how things change, that's a very good example. The North Slope has got a huge amount of natural gas. There's the giant field at Prudhoe Bay, which is 24 TCF, and I think that's a conservative number. As JR mentioned, we're recycling 7 to 9 billion cubic feet a day is going back into the ground. To the east of Prudhoe Bay, there's the Point Thompson field with 6 TCF. And that's a field that, and if anybody wonders why we haven't commercialized this gas to date, it's pretty simple. In the early years of developing the Prudhoe Bay field, the more gas you took away, the less oil you could produce. And despite the fact that Alaskans didn't really accept that, there were some oil company CEOs who didn't accept that. That was the prevailing theory of the major owners. And so it's always required a very large scale project to move crude oil gas. It also has a lot of CO2. On the other hand, over to the east at Point Thompson, you've got a situation where the more gas you can take off, the more methane you can take off, the more valuable gas liquids you can ship. And so our concept there, and also looking at stranded gas over on the tip of the Northwest Territories, you have a situation where if you could do direct export and avoid the long costs of a pipeline, you might be able to get going. And I mentioned Yamal is a 2,600-mile trip through the ice to the Bering Strait, where the sea ice dissipates. We would be only 600 miles. And that's, and as I'd say, the Russians, with 14 ice-strengthened tankers, have been running 16.5 million tons of LNG a year, either to Europe or to Asia or both, since 2017. So ice breaking makes year-round Arctic transportation of LNG possible. You see the tankers here. They're known as double-acting tankers, a V-shaped bow on the bottom when you're in open water, a spoon-shaped bow on the top when you're in ice. And most of the Arctic ice that you encounter these days is annual ice, so it's fairly easy to navigate, except really during times of breakup, where you might be a little bit slower, but that's the tanker situation. Our concept is what you see in the first picture there, is to build a pipeline 6 to 9 miles offshore of Point Thompson, where you've got water depth, which is greater for a turning basis for the basin for the tankers. It's also further out to avoid any complications with whaling. And we would have a gravity-based structure that's there. We will be in feasibility reviewing 2 other options that are looked at with pretty much every LNG plant. One is to put the gravity-based structure inside an artificial harbor out there, which may allow other kinds of projects to also be covered in that harbor. And then there's the idea of bringing modules ashore, which we've been doing at Prudhoe Bay since the 70s. We believe we are the North American LNG project with the lowest greenhouse gas emissions. Alaska gas producers have done a tremendous job in avoiding fugitive methane compared to most of the other gas production in the country, certainly with the fracking gas production. And we believe we beat Kitimat on that. We certainly beat U.S. Gulf Coast LNG on that. And one thing that's not very well known, but we are about the same, exactly the same distance to Tokyo as you are from Kitimat in British Columbia. To take our gas by pipeline 800 miles down to Nikiski moves it 40 miles closer to Tokyo. It's not really the best way to do it. Recently at Gas Tech Hanwha, which made all these tankers when they were DSME, made the tankers that I showed you before, rolled out a concept for an ocean-going hydrogen tanker, liquefied hydrogen tanker with an 80,000 cubic meter capacity. 80,000 cubic meters is compared to an LNG tanker. Standard LNG tanker is about 175,000 cubic meters. So if we were to export liquefied hydrogen, you would need probably about 9 of these tanker loads to carry the same number of BTUs as you would in one LNG tanker. Thinking about it another way, it's about 50 cents to $1, depending on your amortization schedule, your operating costs for an LNG tanker to take 1 million BTUs of gas from Alaska to Asia. All right. So to take the same number of BTUs as hydrogen might be $4 to $8 per million BTUs. And the question, as we looked at the TEA, and I would just recommend in the TEA, we take a good look at shipping as one kind of an issue there. So that's where, but this is a coming technology besides what you heard from JR about ammonia and methanol and other ways to convert natural gas to this. I'll also say that as our customers have asked us to think about ammonia, one of the biggest issues with ammonia, and I'm a veteran of Exxon Valdez, if you have an oil spill, you can see where the oil is. Can't clean it up very well, but you can clean it up. And in the case of ammonia, when ammonia mixes with water, it becomes very dangerous. And we don't really have good shipping standards for ammonia. What we were shipping out of Cook Inlet was pelletized ammonia. And this is an issue that I would just add to the, in order to create a market for geologic hydrogen, for all hydrogen, we need to understand the safety issues of ammonia much more. But I'm going to conclude by saying that I believe geologic hydrogen is a game changer. But we just need to remember wellhead prices of $1 a kilogram are equivalent to $8.80 per million BTUs of natural gas. That's about what Anchorage customers are paying at the wellhead for Hillcorp's natural gas now. So is that competitive? Yeah, if you can hook right into a pipeline system. If you got to then transport it, just remember what I said about the tanker issues. You're talking about maybe $4, maybe as much as $8 per million BTUs to bring it to market. So that is a question of whether or not $1 a kilogram is a good price. To put this in perspective, natural gas prices today, the Henry Hub spot price 2 days ago was $2.03. The JKM, the Japan-Korea marker spot price in Asia for LNG was $13.65. So I could see a case where you could take the $8 hydrogen and $4 worth of transportation and meet what is today's current price of LNG in Japan. And I think if we just all remember that we're clearing into a market of clean BTUs, and it is more expensive to take the CO2 out of hydrogen, but out of methane. But let me just say that's my second point. I'm on the board of a company called a company in Calgary, which is developing several different catalysts for oil production, for natural gas decarbonization. And we believe we've now come up with a catalyst that dramatically reduces the cost and the energy intensity of steam methane reforming. And so that clearing of hydrogen into the marketplace, even up against what you just saw in the TEA this morning, I think the numbers are going to get quite a bit better if our pilot project proves up. Ammonia from natural gas, there is a demand for it in the marketplace today. It's helping to improve the carbon intensity of coal power plants. People are putting ammonia in existing coal power plants to reduce the carbon intensity there. And it's being used in steel to replace coking coal or partly replace coking coal. But the transport safety issues in that headline are yet to be resolved. And I guess what I would just say is that geologic hydrogen production will have identical transportation challenges. It's 5 ammonia tankers, 9 hydrogen tankers of the size outlined in the last slide that are needed to carry as much as energy as 1 tanker of LNG. And I will just say that I expect that in the next 30 years, we will have a clearing market for clean hydrogen from natural gas. We'll have a clearing market for geological hydrogen. We're going to be competing together. And if we can manage the CO2 or manage the carbon from natural gas, and there's several different ways to manage it, it's a worldwide jump ball, we are going to be in Alaska a hydrogen superpower. Thank you.
Well, good morning. I've been told one of the worst times to speak at a conference is on day 3, because usually everybody is out on day 2 in the evening partying up, but I don't see too many bleary eyes this morning, so I think I'm all right. So I want to talk about Granite Creek Copper. I think somehow I ended up being a very unusual addition to this conference, and I believe I'm the only group here or company here with an actual project in geologic hydrogen in Alaska. So if you go to Granite Creek's website, you'll see we announced on Monday the acquisition of 2 projects in Southeast Alaska. They are the Duke Island project that we have signed an agreement with a sister company of ours to acquire, and the Union Bay project, which we acquired by staking. And for the geologists in the room, there's actually some core at the back table, which I didn't know was going to be here, and it's the first time I've ever seen it. So it's very exciting to actually see the core from my own project. So I stood up the other day and said that half of everything that that you will learn at this conference may be wrong in 12 months. So as a publicly traded company, I need in my presentations to put a forward-looking statement. If there's any investors in the room, half of what I say here may be a total lie in 12 months. So that's a double forward-looking statement. But anyways, just a cautionary note, if you are going to invest in my company, just be very, very aware of that. So here are our two projects, Union Bay and Duke Island, again in Southeast Alaska. They are, I don't know if everybody knows this, but there's actually a type of ultramafic known as an Alaska type ultramafic. So not only do we have ultramafics, but ones that's specifically named after Alaska. So these are Alaska Ural type concentrically zoned ultramafic bodies. And what that means is for the non-geologists in the room, that there's different crystallization phases of the ultramafic, and they form in concentric rings around a center core. And this will be significant when I get further in. So the mineral that we're looking at, and we're focused on stimulated hydrogen, just to be clear for these projects. The mineral we're looking for is olivine, or the rock type is dunite, and we know we have that. We know from previous work that there's significant iron in both of the systems that we've acquired here. The projects are close to Ketchikan, so there's good access, and of course they're adjacent to Tidewater. Another interesting thing about this slide, if you see the other Ural Alaska type ultramafic complexes in Southeast Alaska, so if we're successful in showing that these two projects are one of these projects, our perspective to stimulated hydrogen opens up the entire belt for other potential projects. So this is what we're hoping to prove. So we're looking to prove that the rocks that we have are prospective for stimulated hydrogen, and this would be a model of how that would be developed should we be successful. One of the other things that we're looking at is the heat gradient. So if you look at ultramafic complexes more in the center of the continent, the older cratons are much cooler. You'll get maybe 25 C per kilometer depth. Out here in the Cordillera or the more tectonically active sections, you get much higher heat gradient. So the idea is if you could inject water into these systems, it would naturally turn to steam if you're deep enough down. And that's going to be about the 2 kilometer range. So getting into a little bit more of geology here, as I mentioned, what we're looking for is olivine, but it's not just olivine. So olivine is what's known as a solid sequence. So on one end of olivine, you get high iron content, and the other end you get high magnesium content. If it's high magnesium content, it's known as phosphorite. If it's high iron content, it's known as phaelite. We are looking for the phaelitic or the phaelite olivine. Turns out the phaelitic olivine is not that common. What we've seen here in the papers on Duke Island and Union Bay, we think the iron content in the olivine is going to run around 20%. We probably need a little bit higher to actually stimulate the hydrogen. And what we suspect is that it's not going to be pure olivine. It's going to be a combination of olivine and pyroxene that's going to give us a sweet spot to be able to develop those resources. So we're looking for rocks that aren't necessarily high olivine content, or they're high olivine content, but they have some other mineralogies in them to assist that reaction. So this is a geologic map of our Union Bay project. And you can see the dunite, which is over 90% olivine, is in the core. And then you get these concentric zones with decreasing olivine as you move down. And what this represents is the temperatures that the minerals crystallized at. So the higher temperature is the dunite, and the lower temperatures are the gabbros. And again, we think that the sweet spot is somewhere between the dunite and the wurlites, but we need to get into the field and determine that. So some of the challenges that we're facing with exploration for geologic hydrogen is that even though there's a lot of geological information about these projects, they were looked for other commodities. So geologists here recently looked for nickel, PGMs, and in some cases iron. So some of the lithologies that they looked at, they mapped, but weren't extensively sampled. So we need to go back and look at the places where we can identify the rocks that is a little bit weird for me as a prospector, in that I'm looking for rocks that are actually unmineralized, that are unaltered, that are fresh and new, that we can have a second look at and see if they're prospective. So this is, we have another project in BC called the STAR project. This is a dunite sample, high olivine content. You can see the green mineralization there. And one of the interesting things that we are advising our field crew to look for is highly weathered rock. So you see on the STAR project, the rhyolite sample in the center there, you can see a rim of weathering around that. That tells us that the rock is highly reactive, that is, as it's exposed to water on the surface, it's had the reaction that we want to stimulate at depth. And then on the Union Bay project, you can see that quite extensive rim of the beige colored weathering as well. That tells us we're at surface anyways, we're likely in the right place. Everybody has seen this this image already, but one of the things you'll see on my badge, what we're looking for additional targets. In Alaska, in the lower 48, and in Canada. What we're trying to do is build a project generator company where we'll have multiple projects that we'll do initial work on, and then we'll find joint venture partners to advance those. So we're looking for projects not only in the stimulated space, but also in the reservoir space. And so we're looking at the thorium uranium projects. We're looking at deeply buried ultramafics and other iron-rich rocks, and we're looking at the magnetite to hematite reaction that maybe we can move down further in the crystallization sequence in ultramafics, so we may not have to be right up at the top. So just from the investor standpoint, just to point out where we are in a development profile, this is one that I use quite often talking to investors to show where a good entry point for investors. That middle dot there is where my copper project is in Yukon. So investors see that as a good entry point. We are at the geological concept stage, highest risk possible to get in, because like I said, what we know now may not be relevant in a year. So, but we can see a timeline for development here from where we are now through to construction. And when you add those up, you're in the sort of 10 to 15 year range from discovery through to construction. If anybody knows of a fellow by the name of Pierre Lassonde, Pierre Lassonde developed this concept. This is called the Lassonde curve, and it helps investors sort of understand where the project development and what the risks are. Capital market challenges. So as a junior explorer, we go and we raise money in the capital markets, and the game is we try to find something that's worth more than the money that we raise. Challenges where we are is that there's nothing to point to. I can't tell investors that, you know, this is what the this is what we're trying to get to, because there's very few examples. There's one commercial production in Mali, and it's minuscule. Early adopter investors can be very fickle. If they don't get a return on their investment in a very short time frame, all of a sudden you see your share price dive because your investors are leaving in droves. There's lack of institutional investment in the space, because really institutional investments wait for the early adopters to exit before they come in or to stand by. And there is uncertainty in regulatory framework for tenure and permitting, not just in Alaska, but in other jurisdictions that we've looked at as well. So lots of risks, and we've seen a couple companies that we know are active in the space, and the Quebec materials. Most of that stock price rise is based on news releases on their geologic hydrogen exploration, and they are at the stage of taking soil samples. So we can see that if you spin your story right, you can get attraction in the public markets. But then Max Power, who are starting to drill in Saskatchewan, we can see the opposite, where their stock price is going down. There's lots of reasons for that, but I just wanted to point these out to say that there are some companies like ourselves sticking our toe into the space, and we hope that there's some good things to come. Just a couple comments on our team. So because we know that geologic hydrogen is going to straddle both hard rock exploration and oil and gas, we're building our team. Dr. Danny Gobler is an ultramafic specialist, formerly worked for Robert Friedland in Ivanhoe in the big South African ultramafic complexes. We've got Greg Lynch, who has worked most of his career in oil and gas. And we've got Albie Britz, who's a structural geologist, again, with a specialty in ultramafics. So those technical people we've added to our company as we're moving into the geologic hydrogen space. And just wrapping up, again, where our company is, you can see our stock price down there. So one last pitch. It's an excellent point to get in, but do your due diligence. Thank you very much.
Thanks, Timothy. That's super interesting. So we don't have much time for questions. I didn't see anything in the Slido, so I'm just going to ask each of you to just quickly answer a question. Each of you represents the private sector. Our next panel is going to represent the public sector more, especially from the state perspective, looking at both a couple of state legislators, state senators that have been very engaged in energy issues, and also our state agencies. And so just quickly, like what do we need? What as a state do we need to be focusing on from the public sector? And I'll include myself from the university in that as well. Just super quickly, what do we need? And I'm just going to have you guys go down the row. Who wants to start? All right.
Number one thing from us, from industry, is security of tenure. We need to know when we go into a jurisdiction that we can have the rights to the commodity that we're looking for, and that those is going to be reasonable. And right now, I know it's something that is not clear yet, and I know it's being worked on in Alaska, but that's our number one issue, is that security of the rights that we're looking for.
I think for us, it's to get federal support to do the pilot, and we'll learn a lot from the pilot, not just on the technology aspects, but also on permitting, which we think will be a major challenge.
Yeah, I said this during my speech, but yeah, I think concentrating on making sure that the products of hydrogen or hydrogen itself can legally be used to do things that are valuable once you have them, because you need to develop the market.
Clarke, I wear a bolo tie here just to get your attention. I think we've been way too focused on pipelines as the solution to natural gas for a long period of time. And and it's not to say that I wouldn't love a pipeline. I'd also love to fly home to Anchorage in a 747 tonight with a bowling alley. I just don't think it's economic. But the main thing is this, is that what JR is doing is he's doing value added from a resource we have. What we're doing is we're putting together an export model that can work if we find major sources of geologic hydrogen as well. I think we have to understand that we are in a market where we clear into these things, and there's several things that we can do as a state to understand this. There should be a geologic hydrogen research plan. I hope that's what we talk about this afternoon. I think we need to look at safety of transportation and ammonia and really understand that. It's not well understood by the Coast Guard. They're not working on it very well. It's not an IMO thing as yet, and we need to get there. On permitting, we have a permitting challenge in terms of federal law. In only one state, Alaska, does not allow us to go outside 3 miles, though I see somebody here from Bohm, and I think we may have a way to do that if we're courageous. But I mean, there are several different things that the state should do to foster its opportunities and not just focus on one idea, which is the most uneconomic natural gas project I've ever seen.
Thank you. Let's give our panelists a round of applause here. Thank you very much. I'll turn it back over to you, Barb.
Thank you so much. A couple quick announcements. One is we have Slidos in addition to the Q&As, and we would really like you to enter answers into the Slidos. This is important information for the USARC and for everybody. Secondly, if you need to leave early today, there's a box back there for your name tags, back by Where's Waldo character. Wave your hand. There are also some forms that we didn't use. You're free to take them because they're paid for. And then come back now at 10:40. It's going to be a fairly quick break. 10:40. Right now it's 10:30. You got 10 minutes. See you at 10:40.
Yeah, I mean, introducing Mark, it's we all know Mark at this point in time, but I first got to know Mark when he was my boss. He was commissioner when I was state geologist, and Mark was a commissioner of the Alaska Department of Natural Resources. Mark was a great commissioner. Before that, he was also the director of the Division of Geological and Geophysical Surveys, and also at the same time the director of the Division of Oil and Gas, which is just an insane thing to contemplate. He has also been the director of the USGS. He has been the University of Alaska's vice chancellor for research. And he is currently on the Arctic Research Commission. And I'm sure there are things in there that I don't know. You have a PhD in petroleum geology, I think, from the University of Wisconsin. Is it from here? Sorry, from here. And worked in the oil and gas industry before working on policy issues across, well, I guess, state and federal entities. So it's really been a pleasure to work on this with you, Mark. And here you go.
Well, thank you, everybody. Before we start the panel, actually, the Slido question, if you had more responses to that, great. You can think about putting them in. I'm really delighted to have this panel here. And we've heard a lot of questions and desires to really understand what information policy makers need, and then what policies do we need in the science community. Both are true, and both are real open questions. We heard from the last panel from a business standpoint, from mining, from LNG export, from hydrogen economy, kind of questions that they need in terms of permitting and other areas. But now we're going to hear from really resource managers up here and really senior legislators on their views of what they need from you and what they think is going to be needed for policy with respect to legal frameworks, licensing frameworks, environmental frameworks, funding mechanisms, anything that's you might want to ask. I think they can address here. But I want to introduce the panelists first. We're very fortunate to have them. I'm delighted to have and this very impressive panel. And I'll start from my right and move to the left. There we have Senator Cathy Giessel. And I say Senator Giessel is co-chair of the Senate Resources Committee, the key committee, in my opinion, in the legislature that will deal with resource issues like hydrogen. But she's also someone that gets her hands dirty by understanding, in a sense. We shared a trip about less than 2 weeks ago in Iceland, looking at geothermal wells, looking at geothermal sites, understanding that, looking at a small hydro plant. So she has gone out of her way to really understand the science, really understand the implications to people on the landscapes where this energy is being developed. And so she's also a born and raised Fairbanks person, I believe. So she brings just a wealth of knowledge and hardworking ethics. And I've had the privilege of testifying before in the committee, and you better know your stuff, because she will. So Senator Giessel's going to be our first speaker, but I'll move and introduce. Next to her is Deputy Commissioner John Crowther. John and I go way back in terms of our working relationship, but John has got a tremendous background. He's got a legal background from very elite law school and a bachelor's degree in economics. John has worked for the state of Alaska, and he's worked for Senator Murkowski on the staff of Energy and Natural Resources, so he understands Congress, he understands energy policy. He's worked as, I think, head of the governor's office in Washington, D.C., again, representing the state of Alaska in a very competitive environment in D.C., and he's been a deputy commissioner at the Department of Natural Resources, where we work together. And John is, in my opinion, the expert on energy policy within the department. And he, under his tutelage, is Division of Oil and Gas and the Geological Surveys. He also has to deal with many of the tough legal and regulatory issues that DNR faces on a regular basis, whether it be on agriculture, or whether it be forest firefighting or fisheries, et cetera. Not so much in those areas, but he certainly has legal advice on those, but particularly on the energy issues and energy planning, oil and gas lease sales, things like hydrogen, geothermal, et cetera. And next to John is already announced Dr. Lance Miller. He's someone I've known actually for more than 35 years. We first met on a coring job on the North Slope of Alaska. So we met on a rig where, yep.
In the mud room.
In the mud, he was the mud logger. I was a geologist picking the core point, and it was great fun. And then since then, he went away and decided he needed his PhD in both structure and minerals, and has worked in the mining industry for 30 years. I guess he got scared of those oil rigs after that time being a mud logger. But also now is the vice president for natural resources for NANA Corporation. So from Lance, we'll get a real perspective on what native corporations need in the regulatory structure and what they think of geological hydrogen. And last but not least is Senator Click Bishop. And I've had the pleasure to work with Click over many years. I call him a Renaissance senator. First of all, he's a gold miner, and he truly gets his hands dirty with the gold mining. He's also, we shared time in the field in northern Canada on a 48-inch pipeline construction for over a week, looking at all the details, the gritty details of how the welding worked on the pipeline, how the stream crossings went, how the trenching worked, and the speed at which they could build a large pipeline. He was a commissioner of labor in the administration, and he's been a senator for a long time. He's been real knowledgeable on energy issues. He's also mostly an Alaskan, born outside, but then lived in Fairbanks. I guess Lathrop High School, quick. So again, we have local knowledge, but we also have a tremendous background in energy. And he worked on many of the legislative bills, as has Senator Giessel, to shape Alaska's energy policy. So again, a tremendous panel to answer your questions and to give their advice. And one of I think, the two-way communications, what they need and how they need it to make decisions, and what they need from you, but also what the research community and the exploration community needs from the regulatory environment. And I will say, natural resource management, there's people in this room. Could everyone who works for a resource management or a regulatory agency raise their hand? So you can see we have another deputy commissioner. We have people from BLM. What other agencies are here? I guess that's pretty much it. But so we have the major land management agencies and a representative of the native corporation structure here. So it's a great gamut. But I wanted to recognize the BLM people here because they're critical to the decision making as well. So with that, I guess, Senator Giessel, do you want to go first with your remarks?
Well, thanks so much, Mark. And thanks for holding this conference. Mark mentioned that we were in Iceland about 2 weeks ago. Gwen, Holdmann, and ASAP, Alaska Center for Energy and Power, had set up or been part of setting up an Arctic Energy Forum. And, Gwen started her segment with a quote asking you, what the quote was about. It turned out to be geothermal heat. Well, she also shared another quote at that meeting that I'm going to share with you. The quote is this. It's two pieces, but the first piece is, the only way of discovering the limits of the possible is to venture a little way past the limits into the impossible. Any sufficiently advanced technology is indistinguishable from magic. Indistinguishable from magic. So that quote comes from a man named Arthur C. Clarke. He was a sci-fi writer, science fiction writer, and he wrote the screenplay for 2001, A Space Odyssey. So I think about that quote, and I think about hydrogen and all these other ways that we have found to create energy. My reason for being here is my concern for Alaska. Science is critical. I am so thankful for the Alaskans that we have, such as Mark Myers, Steve Masterman, Aaron Whitney, the DNR teams, the University of Alaska Fairbanks, ASEP, and Gwen Holdmann. These are people that care deeply about Alaska, and I am so grateful. They are a resource in and of themselves. But I'm here because I'm concerned about a sustainable future for our state, for our people. I don't want to maintain the status quo. I want a sustainable future for Alaska, not maintaining the status quo, but growing and thriving. And at the same time, preserving this beautiful place and preserving the people who live here and the cultures that live here. So energy, we have a lot of opportunities in energy, and we need the science to direct them. Now, in my world, we have to look at what the state as a government entity gains from these various energy resources. So, of course, taxes are a big piece of it. The royalty, some of which goes into our permanent fund, which in turn funds our government. So that's important. Those are important pieces that we have to solve as this whole idea of developing hydrogen goes forward. Permitting. That's something that we work with the Department of Natural Resources, and Mr. Crowther will certainly talk about that, I'm sure. But another big piece I have to this, my big question is who pays? And we just had this wonderful panel of private sector entrepreneurs, which I love. We've got lots of entrepreneurs in this state. People like Clarke, Senator Bishop, who actually dig in the dirt and find these rocks and do the real work of building opportunities and resources in this state. But who funds all of this? I appreciated the TEA presentation this morning about speculating about what the costs would be. Will those pencil out for our communities? Not just the rail belt. So just for those of you that don't live here, 70% of our population live with direct access to our rail belt transmission system, which is actually a mere extension cord, frankly. But it goes from the end of the Kenai Peninsula, where we have our massive hydro project, Bradley Lake, all the way up here to Fairbanks. It is in tenuous condition. We do have a federal grant to $6.5 million to do a subsea cable from Bradley Lake under Cook Inlet to South Central, because right now we only have one little extension cord that goes that direction. And we had a fire there a few years back that burned that extension cord, and so we were cut off from Bradley Lake. So these are the kinds of basic problems that Alaska has. You're talking about hydrogen. We're still trying to get that extension cord right. But who pays for this stuff, right? We can count on the federal government to some degree. And of course, Alaskans talk about being independent, but we're really not. If it weren't for federal funding and people like Aaron Whitney, who helps connect people, we would be in pretty bad shape. I think another thing we have to do is more collaboration. Now, some of that was brought in here. We had a speaker from Canada. We had a speaker from Finland. Great. When Mark and I were in Iceland 2 weeks ago, Norway was there. Norway is working on manufactured hydrogen and how to deal with the costs of that. We need to be collaborating with our fellow Arctic countries. In that vein, British Columbia and Washington State are collaborating on hydrogen. Again, manufactured hydrogen, but the two, British Columbia and Washington State, have ponied up money to hire a consultant to look at the economics for both of them, manufacturing hydrogen, what would it look like for the production, the transportation, et cetera. But these are two states here, or two entities here on the Pacific Rim. We should be partnering with them. We should be collaborating. What are they doing? How do we fit into that? How do they fit in to what we're doing? The other piece of collaboration is, as I look around the room, this was a great science-based presentation. 3 days, it was great. But there are people who should have been here and are not. And those are the people that live in rural Alaska, who will be impacted in any rural development. Alaska Native corporations, village corporation leaders, residents of rural Alaska. You know, there's a social license that needs to be obtained for any of these projects if they're going to be out in rural Alaska. Folks in our rural communities have been negatively impacted by science projects and research development projects, and they're pretty skeptical. If we're not there, if they aren't invited at the beginning of these discussions, there's going to be a lot of skepticism and fear. What will this do to the fish, the wildlife, the environment? So my recommendation is the next few meetings we have, that these are folks that should be invited. I'm also concerned about workforce challenges. This university needs more funding. I'm a huge fan, but so do our K through 12 schools. The trades need more funding to continue to educate folks to prepare for this. And I was just listening in on a conversation that Aaron Whitney was having. Without secure energy, our nation does not have national security. We're the closest country to the Asian countries, Russia. We have Russian and Chinese aircraft bumping against our border. Our military bases have to pay huge amounts for energy. We need to make sure that we're collaborating with them and we're all working on reducing the cost of energy so we can have functioning military bases here for national security. Deputy Commissioner Crowther.
Well, I'm going to be like Abraham Lincoln in the sense mine's going to be the Gettysburg Address, 2.5 minutes, so we can hear from these other folks. But it's a very comprehensive schedule. I did text Gwen Holdmann and said, do I get an AA degree after this is concluded? I would like to say, just to segue with Senator Giessel's comments, getting back to rural Alaska for a minute, but not only rural Alaska, urban Alaska. Those of you that don't live here, I asked a question yesterday. So what do you pay for, what's your utility bill? And I was told, well, I don't know. And I said, you just answered my question. It's so cheap, you don't care. We pay 30 cents a kilowatt here in Fairbanks right now. In our village in Manly right now, in our other cabin, it's $1.10 a kilowatt hour. She's right on the money. If you're going to move Alaska forward, you have to lower the cost of energy. Here's another tool in the toolbox to do that, hopefully. So I just want to say that Alaska is open for business. We have world-class rocks. Hopefully we got them in this area as well. I'm here standing ready, willing, and able to help, although I'm not going to be here after January the 15th, but I look to be helping in other capacities as well. The big takeaways for me yesterday and today is this tenure on these leases. That's something that can be fixed. The gentleman to my right could lead the charge, no pressure, but and you have a co-chair of resources there that's the hardest working senator in the business that knows how to shepherd this through. And we have a great roadmap. We've proved that we can do this because we just did it in Senate CS for House Bill 50 on the CCUS. So we just recently completed. So I agree. The second thing is we need to bring all hands to bear on this mapping so we know what rocks to look at, where targets to go for. And I know that Senator Giessel and I both have been a champion of DNR and their budget because we've both served on that budget committee for the last 12 years. And we need to, again, more money into DNR's budget to help with this mapping. And any federal dollars that want to come our way, please do that. you know, we could, that will help us. I'm the internal optimist, and I'm very excited to be here at this presentation. A lot of it went right over my head, but I understand some of it, and I'm a big proponent of it. In my energy whiteboard in my office, hydrogen is on my whiteboard as a key fuel source for aircraft. We have the third busiest airport cargo hub on the planet, and I want to maintain that in Alaska to grow our economy. Lastly, I just want to say thank you all for being here. I have learned so much from you. And just one little plug to Dr. Meyer, my good friend. A long time ago, him and I and our gas team went into the Houston, Texas, to the Mobile Exxon boardroom. And when we got out of our Chevrolet rental car and there was nothing but Audis and Porsches and Land Rovers, I said, boys, we're outgunned here. And we walked into that room with 6 of us, and there were 20 double-breasted suits in there, but it was a fair fight because our 6 were as good as their 20. Thank you.
All right. What I'm going to kind of do, and speaking to tenure, and then John can follow up on the state side and permitting, but one idea is how we can, some lands that we can take care of the tenure right away if the social license is there. Also wanted to say that I just realized, I don't know how many of you are active investors in hydrogen. I actually am. Okay, I am too, because as I got to know Tim, I was part of a private placement in the formation, the metallic group companies, of which Granite Creek Copper is one of them. So lo and behold, I'm in. So what I want to do here also is give people a little background, because I've talked to several folks who are not from Alaska about ANCs, just a little story. And then the other 2 points here, potential lands that could be used for demo projects if the geology matches, and a specific example of the kind of project where you could have a targeted potential hydrogen development if it was close to fuel industry. So let's see, okay. ANCSA, how many of you have never heard of ANCSA? All right, good, oh, awesome. Alaska Native Claims Settlement Act, formed in 1971. Quick story, the real reason was because with Prudhoe Bay discovered in the late 60s, needed a pipeline across native Aboriginal lands to Valdez. That wasn't gonna happen. One of our early leaders at NANA, Willie Hensley, wrote a paper in college talking about the need for a Native Land Claim Settlement Act. I think originally the goal was around 100 million acres, which in my opinion probably would have been closer to what should have happened going to Native Corps. 44 million acres did go to Native Corps. In that legislation, there was 12 regional corporations formed, one of which I worked for, NANA, up there in the Northwest. These are for-profit private corporations, along with some couple hundred village corps. Today, there's about 170 village corps, I think. And then I'm going to talk a little bit more about the Red Dog Mine, which is that star up in the northwest portion of the NANA region there. So that's really quick, I know, but got to keep going. So what we have, and on NANA land, so part of it was that resources would help propel Native Corps, give economic sustainability. What was discovered was the Red Dog zinc mine. It's the largest producer of zinc in the world. It's been going, as you can see, for 35 years. It's the largest critical minerals mine in the United States. Zinc is a primary revenue generator, about 80% of the dollars it produces. Lead, silver, and actually the US's germanium. But it doesn't really, even when you follow the track, it doesn't quite come from the US because it's produced at the Trail smelter in BC, which is owned by Teck. So NANA owns the subsurface, and we have an operating agreement with Teck Resources. Picture the mine in the background with some caribou there. Kind of a classic picture. We are projected to close right now in 2031. There's active exploration going on to continue that for decades. So that's a lot of my time and effort. And just a little bit about the benefits. So why it's important. There's a section of the Alaska Native Claims Settlement Act called 7I, which means, which requires 70% of any net revenue that comes to an ANC is distributed to all the other ANCs. They in turn have to distribute 50% to the village corps under 7J. Okay, this, I won't go through these numbers, but it's just showing the kind of the statewide and global reach of Red Dog. And I think Red Dog, speaking of what, Senator Giessel said, yeah, there's a lot of kind of bad stories out in rural Alaska, but this has street cred, 3 generations of NANA shareholders working there. As you can see, 900 shareholder jobs. It's 50, 60 million a year in wages. It supports the Northwest Arctic Borough about 85% of the base budget. And it's a really cool story, though. The borough was developed for self-governance up there using the mine. The early leaders deliberately, hey, we got Red Dog, how can we form local government for self-determination? Anyways, on and on. Very cool story. I could keep going, but I won't. But the 7I piece is important for all these other ANCs and village corps. There's something out there, there's been articles published called the 7I Cliff. It's estimated that about 2/3 of the some 170 village corps are fully or partially dependent on 7I to keep the lights on, okay? I just spoke at Alaska Law Conference for their continuing education with Aaron Schutt, the president of DOI, on this topic. Some of these slides came from there. And you can see what NANA has distributed from Red Dog through last fiscal year is $1.92 billion from mining. So total 7I has been about 4.6 billion. Minerals overall 7I has been over 42%. So people think of oil, but it's actually zinc that's paid the majority of all 7I distribution. And again, it goes to all these other regional corporations and then to the village corps. And you can see some of the numbers in the last 10 years, rough numbers, 69, 70% of all 7I has come from minerals. So it's been pretty significant and kind of a cool story. Tim showed the Lassonde curve, and I hate to, he's on, again, I'm an investor, so I shouldn't put this slide up, but it's not 10 to 15 years. It never will be again, unfortunately. And in the US, the average is 29 years to get to a mine. On the bottom there, I put blue bars for each stage, from exploration scoping to decision. Red Dog even took 19 years. We have a mine up there or a property called Bornite, another one, Arctic. Bornite's 75 years since the first drill hole. Okay, so you gotta have patient capital for these projects, and I fear geologic hydrogen. Well, who knows? And then just kind of to wrap up, so a couple of the ideas here is, if we're looking for places to do this, and here is a map, obviously, of ANCSA lands, mineral occurrences in dark, and the lighter, whatever it is, gray, is all mineral deposit state land. So I didn't put ophiolite belts and things like that on here yet. We'll do that later today. But point being that the ANCSA lands were selected primarily for subsistence and resource development. So when it comes to minerals, they pretty much copy all the mineral belts and all the orogenic belts in Alaska. There's great opportunity. Specifically, now for the targeted approach, Red Dog consumes about 25 megawatts of power. And in the NANA region, there are ultramafics and mafic rocks. Some of them are serpentinized, so I've now learned that the hydrogen's probably long gone. But who knows? But that's the kind of thing. It's stranded, 52-mile road from the mine to the port, where we take the concentrate. What we ship is concentrate. Goes to about 8 smelters around the world to turn it into metal. But power is key. And we have to bring in diesel. Then, if you could do that and get some advantage for the villages, it's a double win. And then this slide is just kind of a different view, same one, but showing the ANCSA lands again and some of the recent or active mineral deposit projects that are going on today. So with that, thanks. And then I also had something really important here that, and this is why the crowdsourcing and that Slido is good. Remember, why does a volcano erupt or spew? And there was an answer from the crowd for the lavette. And then yesterday, I think it was Aaron said, we were like volcano theme. How does a volcano erupt? Anybody know? Through its ash hole.
Well, I, of course, was going to open with some hilarious jokes, but since that cannot be exceeded, I'll probably just start talking about land position and regulatory issues. Excuse me. Yeah, so John Crowther, Deputy Commissioner at our Alaska Department of Natural Resources, and I hope most folks yesterday got to hear our commissioner talk, which I think he did a tremendous job talking about the history of Alaska, the overview of kind of how we got here as a resource state, and of course the senators, both of them talking, they're the ones setting the policy, and their personal histories with it is enormously relevant and illustrative. But that theme of facilitating use and development of our resources is, the constitutional obligation of the department. It's kind of in the DNA and psyche of a lot of Alaskans. And so I think, for all of you looking either at the research, pure scientific stage or at the development stage, if we get there, Alaska is a place where at least we want to be at the table in the discussion, very involved. And so I think that I'll touch on a couple different quick things and then leave time for questions. And of course, it's usually the senators are asking the department tough questions. And so of course you're encouraged to ask the senators all the tough questions, and I'll just kick my heels up for the question portion. But terrific to hear about the Alaska Native corporations. I think that's a really important thing for folks conceiving of projects or research to understand that land position. Lance was a little modest. The Alaska Native corporations at scale, many of the large regionals and even some of the village corporations are Fortune 500 size companies in terms of sophistication, revenue. And so they're corporate titans that and functionally have a lot of capacity in business in Alaska. So if you're doing frontier research, you'll find yourself working with crews from Alaska Native corporations, working with folks who are employed but who also live in the region and have that history and personal knowledge. But so that land position, the Alaska Native corporations, they have the ability to do those deals to facilitate research, to do leases, to negotiate. And so they have a lot of flexibility. When it comes to the state lands, of which the commissioner outlined, we have 100 million acres of state uplands. And the map, one slide back on the NANA slide, it's very rare to see a map where there's little dots on it, and that sums up to 44 million acres. Sorry about that. 44 million acres of lands being little dots on a map. Alaska, we have 100 million acres of lands in state ownership, and it's still just a portion of our state. But I would say that that's from my perspective of the department, that's a very complicated question. We have all this land position. We have a relatively novel and uncertain resource potentially on it. What do we do from an executive branch side to facilitate, encourage, solicit the research that's needed, but potentially the investment as well? And one of the things I did want to talk specifically about, we, as Senator Bishop referenced, we just got through a public process, a significant process about carbon capture, utilization, and storage in Alaska to facilitate storing carbon in our subsurface geology in Alaska. And so that, in my mind, is in some ways a very relevant model as we look at hydrogen questions about tenure, about leasability, about land position. what do we do to address that question, to frame those questions up in light of all of our experience in our comprehensive framework for things like oil and gas, for mining that have happened in Alaska for a long time. And so a couple of things I would note from that experience with our carbon capture legislation. The first was we worked with the university, with industry, with a consortium of groups to develop a work group to study, not just the science, not just the technical feasibility, not just the economics, really everything, kind of an open discussion. What are other states doing? What is the use case? What are businesses saying? And all of that information, which we had multiple facilitations by the university, went into developing, white papers internally, went into developing surveys that we sent out to other states. That was very, very useful for us when we were developing kind of a public policy proposal. When we take it to the legislature, as Dr. Myers mentioned, Senator Giessel is as our resource chair, an extremely focused, on the details, on the interplay. Senator Bishop referenced, the local economy, how to move Alaska forward, how to change those energy costs. Those are the questions that they have to balance, go across everything. Where's the state's value? Where's the people's value? What's the regulatory risk? What's the community involvement? What are the second order benefits to change the status quo? And so we wanted to develop as much of that information as we could, so that when we got into the legislative context and we're talking about particular legislation, there's also a comprehensive understanding that we can build, so that the members of the public that are inquiring with the senators, what are you guys doing this session? Why are you doing this? Why are you spending time on this rather than that? That we had a lot of information to say this CCUS effort has major public benefits, is a place where Alaska should be putting its energy. And so I think that same effort, this conference is a tremendous way, it's been focused obviously on the scientific work you all are doing, but it's a very good wake-up call almost to the department to say, this is an area where we need to develop capacity to understand all those different things, the science you all are doing, but also the hydrogen market, the infrastructure challenges, the local use cases, so that we have the ability to, as a landowner, be forward-leaning in, if we've got the resource, what are we doing to make it useful? What are we doing to support the research? And so I think that CCUS example is very illustrative. We'll be working with all the folks here. As mentioned, there's several folks from both our Division of Geological and Geophysical Surveys, from our Division of Oil and Gas, and then Deputy Commissioner Goodrum is here as well. So we'll all be following up after this conference with internally about what can we do to start these kind of discussions at the department. But so I think really the one other thing I would mention and is that at the Department of Natural Resources, we have experience with kind of people trying to do frontier either at the research stage or at the kind of demonstration stage. We have a geothermal program that we've invested a lot of time and effort in. We also received some supportive legislative adjustments to that program to make it more competitive and attractive this last session. And the commissioner is very focused on what can we do to support geothermal resource characterization and support permitting and licensing that's efficient. And so similarly, I think this is a topic that'll fold right into that. We also, I know there's some folks from JOGMEC here. The department worked to facilitate methane hydrate research on our North Slope using existing infrastructure. And that was a key priority of the department. And we certainly think that the investment and focus from our partners in JOGMEC there. But, if there's opportunities for that same kind of research, demonstration sites on existing infrastructure and state lands, we want to work with the project proponents, whether they're private, whether they're universities, whether they're government research entities, to say, we want this research to proceed, and we want to negotiate, facilitate, convene the different necessary parties. So I think I might conclude and just turn it over for questions, but it's very exciting to be here. As Senator Bishop said, some of this went perhaps in one ear and out the other, or over my head, to say the least, but it's always humbling and encouraging to see how much scientific capacity is focused on Alaska and our resources. So thank you.
Thank you all for your focused answers and for your insight. I want to come back to the question of what information do you need from the community? First of all, raise your hand if you'd be willing to provide information, either the state legislature, DNR, or the federal agencies, BLM, if you're be willing to do that. So you can see a lot of people here that are willing to provide, world experts that are willing to provide information. So what would you need from them if you were considering legislation to allow licensing or legislation to support funding for the university or for the DNR to do additional work in this area?
Well, first and foremost, I'm looking for speakers. This will be a subject before the Senate Resources Committee. And so many of you who are experts, I would love to have you speak to our Senate Resources. It's 7 people. I am getting, there's a University of a UAF document. Yes, they're bringing 20 of those to me. I'm handing those out to every Senate member. Just so that, just to inform legislators. The other thing that I'm going to need is, of course, partnership with DNR, because they're the folks that are going to inform me and the rest of my committee what is needed. And having the deputy commissioner here, both of them, is really meaningful because they now can calculate what the gaps are. Do you have more to add, Mr. Crowther?
Yeah, I would just say that, you know, the kind of things we want to understand are, you know, how you know, one of the things that we struggle with when we're leasing and managing our lands is the duration and scope of different interests that come to us. You know, for oil and gas, we know very, very well, we're going to lease this many acres to you at this rate, and the royalty is going to be this %, and the term of it is this long because we don't want to wait. We don't want you to sit and warehouse it for too long, but you need the time to do the exploration and the work. You know, what are those terms for a hydrogen lease? I think we're not at that stage yet, but we need to start thinking about that because we want to have value for the state. We want it, you know, depending on the theory, is it a reservoir underground? Is it essentially a hydrogen generating engine where the state happens to own a valuable rock buried underground that other people are putting stimulating materials in and then getting valuable hydrogen out? How do you value that? What is the contract that we enter into with a private developer? You know, that those terms are not in the oil and gas context. We can go to handwritten stuff from Texas 100 years ago, you know, to see the original negotiations and scope and disputes where those came up. For hydrogen, we need to get there quickly is one of the things I'm taking from this conference, because it's certainly so many areas of research, but there's companies in this room looking at how do we get together the money to do a test project to potentially get hydrogen into the market in the near term. And that means we need to work on how do we contract with those companies to use our lands in the near term. So long answer, but.
I'll add something. I was thinking about that. I mean, of course, with a native corp, we'll just do the deal. The problem is, we'll have to still permit it, but we'll do the deal. The problem is if it's a greenfields project, what do you compare it to? So I could just see the concern will be, oh, you're giving it away, or then the company's like, oh, you're charging too much. So back to need to be coordinated, you know, with the state. But then it comes to that other thing I mentioned about Red Dog, and maybe that's the more I think about it, if there's the potential for hydrogen there, like that doesn't have to be priced. There's a source there. If we can displace diesel with hydrogen and the CapEx and OpEx is cheaper than what it costs us per kilowatt hour to bring in diesel, it's a done deal. The other thing is with Tech as a partner, they have very aggressive net zero goals by 2030. So something like this also would fit in their global corporate goals. So just made me think on that.
I'd just like to add one thing. Dr. Miller's slide on the permitting timeline. I said this 2 years ago or a year ago in Washington DC at an energy conference. These carbon neutral 2050 goals, and I'm not banging the feds out here, but people, we got to get real. They're not realistic. You're not going to get there. It's not because you don't have the science, the engineering, the expertise, and the people. The permitting process is it's got you handcuffed. And that slide was a good illustration. So anything you can do to help us all get to 2050 by streamlining the regulatory process would be great.
Thank you, Senator Bishop. I would just note the department's timelines are slightly in advance of 75 years, and we were going to work to keep them that way. But it is the federal timelines are extremely challenging, and it if it's a multi-generational permitting process, you're not going to get multi-generational employment. So,
If I could follow up with one other question here, I don't want to monopolize it, but the idea of a joint partnership, federal, state, native corporation, is a pretty exciting idea, particularly for the knowledge gained and potentially for then the utilization potentially of that site as well. How NSF has requirements to reach out to tribal organizations and any funding they have. Other federal agencies are looking at opportunities to do that. But that's with the tribal structure, not with the native corporation structure. Could there be a structure through the native corporations that reaches to the issue of the tribal coordination necessary for the federal funding component of this? I'll turn that.
Well, I mean, depending on the agency, of course, ANCs are treated as tribes for consultation and things. Also, I think even some of the DOE funding, because NANA has received a fair bit of it, is some of the same that goes to tribal organizations. So there's vehicles for funding to go to ANCs that are also the tribal funded programs. And that's another thing I didn't mention, but and for people not from Alaska, because we were educating some people from the Corps of Engineers on this, is the tribes are a big issue, big deal, especially on the DC perspective. But just remember the slides up there, ANCs own the tribal lands here. Tribes do not own land. Now, that's a rub with some of them. But all tribal members, like the NANA region, tribal members are NANA shareholders. So they're part of the corporation, and often they'll be part of the village corporation as well. NANA had something unique. We merged, so there's only one village corp. So we do an awful lot of village outreach because of that, because we have representation with the villages. So in a way, I like to think, at least in our region, we work with the tribes constantly. But if you can build capacity, and if they have opportunity for funding, and then work with like NANA on a subsurface deal, whether it's mining, alternative energy service, then that's great. And we are working on some of those with some of the tribes for alternative energy projects. So lots of opportunity.
and just to note for folks who are not at all familiar with ANCSA, and Lance may have covered this, but I think sometimes for us, it just skips over because it's so intuitive and innate. Alaska Native corporations, the shareholders are Alaska Natives, and the shares are not fungible, tradable, negotiable. And so the shareholders who own that corporation, who own that, in some cases, multi-billion-dollar corporation, are the people who live in the region and have lived there ancestrally. So that is kind of one of the core tenets of those Alaska Native corporations, is they're for the benefit of the shareholders, and the shareholders are the people who live there.
I'm so glad that this is being emphasized, because it is another feature that makes Alaska incredibly unique. But the other collaboration that I think about, Mark, is resource development and the military. And Aaron Whitney was just having a conversation about that. You know, Alyeschem here was going to have a small modular reactor. They put out an RFP, it kind of fell through, but I noted articles, letters to the editor, that the community didn't feel conferred with on the placement of that SMR. And that kind of was burr under their saddle. So the more collaboration with communities and the military on resource issues, we're all on the same piece of geography. Energy means a lot for all of us.
Well, thank you. And I just want to acknowledge Richard. You know, raise your hand, Richard, from the Air Force. Very interested in these sorts of collaborations with communities on geologic hydrogen as well. So we do have a very strong representative here from. So we have a question up here. Who would regulate geological hydrogen? And of course, we don't have the BLM leadership here, but they're obviously going to be very important in that process on the federal lands, as is EPA on certain functions, and other federal organizations. But I presume the primacy for this, the major agencies would be the State of Alaska Department of Natural Resources as the lead, the native corporations on their own on native lands, and then the BLM largely on federal lands. But also there is opportunities in the offshore too. So again, I suspect BOEM would be very interested potentially in those sorts of collaborations. So it would be nice, again, if those organizations could come together and have a discussion about what do they want to do in terms of common structure.
Commerce Department, AOGCC, and for the offtake. Yep.
Yeah, and for the AOGCC is our subsurface well regulator. So the department is managing the surface facilities, the kind of land use, and obviously we're setting the royalty terms and the lease terms. But the Alaska Oil and Gas Conservation Commission is is setting the terms for wells, issuing currently class 2. They have, thanks to the legislation, pursuing primacy for class 6 wells for carbon sequestration. But so when we figure out what kind of class well we need for stimulated hydrogen or geologic hydrogen, the state can look at that primacy, and that AOGCC capacity is very significant because of our long history with oil and gas.
Thanks. Again, on the DNR side, I want to make sure we recognize we have the DNR mining and land commissioner here as well. So there would obviously be within the organization's coordinations, very important coordinations internally in all the organizations. Similarly, in I suspect in BLM and within the Department of Interior. Jeff?
Thanks. Something that I think hasn't gotten enough attention in all this is that in my view, there's a very big distinction between drilling for natural accumulations of hydrogen that are in place and the stimulated hydrogen generation, and that the regulations around those are going to be completely different, and that producing natural accumulations is very analogous to natural gas production that we are aware of. Doing the stimulated side, this is white space. This is research. This is something that's never been done before. People say, oh, it's kind of like enhanced geothermal, or it's kind of like some of these other things. Only to a certain extent. It's very much a research thing. We don't know the potential. These hydrothermal reactions can increase the volume of the rock by 40%. And so you can have induced seismic effects. You can have surface disruptions and so forth. So we have to be very, very careful how we move forward with that. And I wouldn't just have a blanket regulation that says, oh, geologic hydrogen, we're just going to allow, this kind of drilling or something. So it has to be thought through very carefully how you move forward on the stimulated side. On all of it, really, but.
I think, sir, that's exactly the kind of information we need from the technical experts.
And if we have agreement of the group, we can push lunch a little later. We don't have to be back till 1, so you'd have a full hour for lunch if we keep going. If there are more questions, again, from the audience, start there. Go to Mead.
This morning, Gwen talked about Iceland, and I had mentioned yesterday, I led a group when I was on the Arctic Research Commission Iceland to talk about geothermal and that challenge. And the question they said to us was, how much are you willing to subsidize your geothermal work in the US? And I said, why do we need subsidy? And they said, well, because it was really a shot in the dark until we figured out the geology and everything else. And I guess the caution I would give to you as policymakers and regulators is, if you have 5 bad oil wells and 1 good one, it makes up for all the bad ones and more. it probably won't happen that way with hydrogen. And it certainly didn't happen that way with geothermal. And we've yet to really have a successful geothermal lease in the state, and we've been pushing it for 20 years. So I would urge you to think about maybe even a general permit for exploration at this point. Just basically say, what are the requirements? It's, almost like mineral prospecting, but without the, Mark and I were talking last night, without the squatting type situation that you sometimes get in mining claims, just to be able to let people go out and explore and maybe have a regulated program that fits with AOGCC. AOGCC can screw this up. We watched them screw it up with geothermal and so forth. And some of the experts I've heard last night are saying, they're very, very concerned about AOGCC treating this as if it's a hydrocarbon well. You can force somebody to put something down the well that can ruin the well. And so I would just say, one, it's, frankly, if we had 100 wells out there that we didn't get much of a royalty from, but discovered a new resource, that would create great royalties over time. And I just wouldn't try to turn it into one single special interest finding for every lease sale. You don't even know what to put up for lease in a lease sale at this point. So that's one situation. And then the other is just make sure that we don't overregulate the industry to get it started, because we don't even know what it is yet.
Dr. Mark? I want to get my Iceland lick in. Gwen's got hers in, and Mark got his in, and Cathy got hers in, and I'm going to get mine in because this might be the last time you see me for a while. I don't think I've ever approved such a completely ludicrous idea as to think that water can be brought all the way to town and that it will be still hot enough when it arrives to heat up entire buildings. You will never get me to believe that this is feasible, no matter how you calculate it. That was from last year's Iceland trip when we toured the power plant. So that was the member of the city council in 1908. And the rest is history.
Mead, I really appreciate your comments. And I would urge all of you, as you watch and you see legislation being proposed about hydrogen, to pay attention and please call in. We take public testimony on these pieces of legislation. We need your input. Certainly you can offer it to DNR also, but we hold public hearings. And of course, when they write regulations, public comment is accepted, and they refine regulations based on public comment. So keep watching and please engage.
Wonderful. Other questions that anyone wants to ask? Allegra.
I would say that this is the most diverse audience I've encountered at a what I thought was going to be a scientific conference. And so, Mark, kudos to you and all of your team for putting this group together. You have all the pieces and parts here in Alaska geologically. You've got experts like Jeff and myself and lots of others willing to work with you. Don't wait on this. This field is moving so quickly. I can't keep up with it, and I work in it all day, every day. At the same time you're doing hydrogen, make sure you lease for helium. It is a major part of the story, and we have not talked about it that much this week, but they're often co-located. And it was announced in Australia 2 days ago that they have a helium-3 find. If you know how absolutely mind-blowing that is, your mind will be blown right now. There's been talk of mining helium-3 on the moon for use here on Earth. That's how mind-blowing my helium-3 discovery is. So keep helium in the mix. Don't leave here and do nothing for 6 months. Keep this momentum going.
Any other last questions? I'll ask one more. the first stages, as you saw from the early presentations, is compiling the data. In Alaska, again, this is the first open door to geologic hydrogen period in the state. Other than the work that was done by Stillwater, now by Granite Creek, but they haven't even, they're just looking at the rocks for the first time. So we are literally at the very earliest stages possible, and we're already, really starting to plan out that future, which is amazing. But one of the things we need to do is to take the data that we have and make it suitable for use for geologic hydrogen. And so that would be ideally done in a way that has been done similar with critical mineral data and done with gravity magnetic data, done with topographic LiDAR, digital elevation data in the state. There's a great model here of cooperation between agencies, between the private sector and the state of Alaska to not only produce but manage those data sets. So that would be an early stage funding to be able to do that. And that could, and I will also put the university in there. Much of that data, satellite-based, is being managed by the university. That consortium could be reproduced to create the baseline data that's needed to do the analysis. And time is of the essence if Jeff's survey group, the USGS team, badly needs that data. They need seismic data, they need gravity magnetic data. They need any geochemical analysis. They need water analysis. They need the mineral analysis that we saw, some of which Sue Carl pointed and other people have put. So I would urge the group to think about that early stage that can really help propel this USGS assessment, allow private companies access to be able to start to understand. So to me, that would be funding for something like that would be really important. And the last thing I would say, Mead, is Senator Murkowski mentioned something like the Hydrate Research Act. And I know a federal act like that dedicated to geological hydrogen would move mountains. And it wouldn't just be Alaska. It would allow better cooperation, more federal engagement of the federal agencies, line item budget authority. And in hydrates, most of the money went to DOE to support DOE's efforts. But that has led to a $200 million test in northern Alaska going on that's revolutionizing what we understand about hydrates. And it took a lot of years to get to that point. It's also helping us understand them in the Gulf of Mexico. But without that act, I don't think that program would be anywhere near where it is today. So an act from the federal government, if we're willing to engage, support coming from the state, coming from Native corporations for such a thing from Alaska, would simply verify to the Alaska delegation they think this is worthy. So that would be my suggestion, one suggestion to consider. The second, again, is getting the data in order, getting the data consortium working, finding those data gaps and trying to fill those. And then Mead, sorry.
I just wanted to add to this, maybe as a preface this afternoon. First trip I made to Washington as lieutenant governor, I talked to the governor. I said, I'm going to see the head of the National Geospatial Intelligence Agency. And he said, oh, I never got to see them as lieutenant governor. What are you doing? And we were actually putting together the last pieces for a digital elevation model of Alaska. Worked with Mark on this and DNR. And we've just completed basically, I mean, it was upwards of $60 million to map Alaska that had not been done before. And we got a whole bunch of federal agencies and state agencies together to get everybody to chip in to make that happen, right? Likewise, we did the same thing when I was chair of the Arctic Research Commission to get Congress to fund what just became the U.S. claim on the extended continental shelf. I was there to kind of help push it through, but I didn't write the plan. It was a group like this, it was workshops like this that wrote the plan. And I really hope one product of this workshop is an attainable Alaska level and maybe national level data plan, sampling plan, whatever, on both sides of what we know, that at least comes up with a stage 1, stage 2, stage 3 number that has federal agencies there and state agencies there, because then people can argue for it. But right now, I don't know whether, what you need for what you just described, Mark, is $2 million for the DGGS budget and another $1 million at USGS, or what? And let's try to get those numbers as far as what's needed, because there's ways that appropriators can figure things out. There's ways that you can do this is an advance on royalties or something, a credit on royalties or something like that. There's stuff that can be done, but we need to plan.
Well, with that, any closing remarks from our panel? I want to give them another round of applause. It's been a tremendous panel. Thank you. Okay, time's up. We're going to go to start our discussion. I'm going to go to where to drill here first. So you guys are on. Who's our spokesperson? Excellent. Okay, Steve.
Yeah, I was way too slow taking a step backwards on the volunteer aspect of this. So yeah, we have where to drill as our question, which we dutifully morphed into how to get to where to drill. And so we made a list of actions that we felt like we would take in order to get to that stage. And the first one was identify critical data sets that we needed to compile to reduce the area. And then it was organize that available data and see what we have. And then thirdly was to fill in data gaps with obviously the critical data sets that we previously identified. And then the fourth thing we decided we would do would be to complete the prospectivity maps that Jeff is looking at completing and add to those additional folio data layers. And those additional data layers will be layering on sort of gas seeps, vegetation signals, target types, land status and permitting, assessing the risks of hydrogen degradation or mixing in the targets so that we could screen out the ones that looked like they were going to be dogs. And then what else have I got here in there? Oh, incorporating tectonics and faulting in as a layer into that folio. And then basically use that folio to identify potential drill targets. And then once we have a selection of potential drill targets, we then need to look at those and prioritize those drill targets, obviously, before we go out and drill them. So in order to prioritize them, we have to develop a series of criteria on which to prioritize those drill targets. And we didn't really flesh that out. And then obviously we prioritize the targets, and then we come up with a list of our top target. And in the words of our previous governor, we drill, baby, drill. So.
Give him a hand. Okay, next group, Arctic Cold Region International Cooperation or Collaboration.
All right, so again, I guess, yeah, we did the Arctic Cold Region International Collaboration. Oh, there we go, can you hear me? And we came up with initially we identified some challenges and some advantages that are probably similarities across some of the countries or areas that are in those regions. And that'd be like permafrost would be one potential challenge. And then there's also like the receding ice and exposing more rock or more areas that might be available for development, or at least looking at. And then some of the other ones would be remoteness and accessing them, especially here in Alaska, where we have a minimal number of roads, and finding things that are in areas that are, you know, developable or can be marketed. And then scale is another one. So between the ones for accessing it and marketing it, if there's a scale where you can find smaller supplies or systems that can support just a village or something nearby, it might provide would be a big advantage, particularly in these regions. And then for methods to collaborate between countries, there's both consulting with the native tribes or First Nations or whatever they are, wherever they are, and including those people early on in the process to help foster the development in those areas and for those villages. And then as well as the Arctic Council, which is a conglomerate of Arctic nations and indigenous tribes to also further the development in those areas. And as far as some of the ideas to collaborate on are generating markets and ways to market the product, and then at the same time, maybe universities or something to help foster, at least with the natives here in Alaska, as far as consulting them and having them approach them for both explaining the ideas and what may occur in the future.
I'm decent.
Okay, we're going to research, collaboration, federal, state, university. Melanie?
So our group started with, we need a consortium. That was kind of a no-brainer. It's a great way to start collaboration. And this workshop has been a great start to this, and we want to see that collaboration continue. Other things we talked about, it's not just the research collaborations, it's the collaborations in terms of funding that we bring to it. And so collaborating applications together between different agencies, you're more likely to get that funding than if you're a sole agency going forward. It's also bringing outside of Alaska to that. We're not just the sole ones looking at this. Other things were bringing the strategic people to the meetings for the collaboration for like that. And so that included adding in private industry, adding in the native corporations, not just what was listed federal, state, and university on our sheet here, making sure that everyone's there at the table so that we get that diversity of thought brought to it. We also agreed that, you know, when you're starting to add agencies up together, you can add in the matching funds, and that gets you help you more funding for a bigger, better pilot, and not just the pilot, but the data collection you need to get there before the pilot. And we came up with a slogan for our consortium. It was North to Future for New Energy Resources. It's a summary, but it's a North to the Future for New Energy Resources.
Okay, now we're at source stimulation.
Well, I sat at the right table because that's what my topic is. So we talked, kind of covered a lot of things, and I think we probably made more questions than answers on this one. We started just asking what it would actually look like. What does source stimulation look like on the surface? And that kind of got us down that path of like, what requirements do we need? That got us down the path of, okay, is this analogous to conventional systems? Is it analogous to unconventional systems? And we sort of mentioned what the point Jeff brought up earlier today, which is these are kind of different. They're probably going to get regulated very differently, and they're certainly going to be tapped very differently. And so trying to think like, what is this actually like? Is it like an unconventional system? That got us down the path of discussing sort of what you're gonna bring on surface, and water became the main topic. So what's the water? You know, what's the water chemistry that you're going to be using? What's the water? Are you going to recycle? Is it going to be more like what we're dealing with on sort of in the Permian Basin, where you basically produce the water, but then you deep inject it to get rid of it? Or are we going to be recycling it? And without a lot of experience on this side, we sort of came to the conclusion that the water that you're dealing with in oil and gas is way more contaminated than the water you're going to be dealing with in fractured basement. And so it's probably not as much of a concern as we have in the kind of oil and gas industry. I said I'd never use this word in this phrase, but we talked about fracking. There, said it again. But basically it was like, what are you going to monitor? When you start doing that, when you do the stimulation, what are you actually going to monitor? The volumetric expansion, you know, is something real. And so are you gonna monitor for that? Are you gonna use some sort of seismic system to kind of monitor the overall effect? Are you gonna try to build up like a water transport mechanism? Like, is the water escaping your volume that you're trying to interrogate? So we got into that. And then we finally said, okay, well, maybe we're overthinking this risk altogether. Like, are the risks really there that we think they are? And if we focus on the risks, are we ever even gonna get to the starting point? And I think that's kind of a realistic thing. Obviously, the public wants to know what the risk is up front. And then we started getting into the fractures, and are fractures good or fractures bad? And fractures are certainly good because it allows you to interrogate larger volume. It's hard to maintain pressure in a highly fractured system. And so engineering around fractured plays is going to be pretty tricky. So there, that's what we did.
Okay, we're now, who will lead in Alaska?
So, who will lead? Yeah, we thought an approach would be to have some of a steering committee, consortium, whatever you want to call it. And that would be composed of people, which then the list gets long, unfortunately. So we struggled with this. So I'll just start high level. Who will lead? We need a steering committee led by a person. We identified that person, but we won't name that person because people could probably guess. How it would sit, would it be in the university or wherever? One thought would be it could be in the Arctic Energy Office of DOE. Not really a program, but at least housed sort of under that. And then this committee would develop a 2-year, 5-year, and perhaps longer term. We were going to say 10, but we thought, nah, just longer term plan where you'd, really we got to figure out what's the prospectivity, what's the real opportunity, where are these targets in relation to infrastructure or uses. And then 5-year, you start getting into kind of pilot projects and so forth. So who would be on the consortium or the steering committee? Really, we don't know, again, the levels, but state of Alaska, you need the science folks, you need commercialization, VC folks, University of Alaska, ANCs, native groups, feds, of course, private sector I mentioned, and then USGS, DDGS, would they fall under the state or under the Fed group? And then the question also for whoever sets this up is, you want high-level people that are connected, but often they don't really do all the work. So maybe one idea would be the first phase of the steering committee is actually people who are just passionate, represent these interests, kind of get it going, and maybe their co-person is a high-level person in each of these organizations. So. Yeah, well, that's where we said we don't.
Okay, creating markets.
Thank you, Mark. So we were given creating markets. I'm going to rephrase it slightly and say recognizing markets and how to get hydrogen to those markets. So very sparsely populated state in Alaska, and hydrogen is really difficult to move. So why don't we maybe merge and try and kill two birds with one stone? Mead earlier today suggested to the DNR that that the state gives explorers a free pass for a period. And we've developed that idea a little bit more and said, hey, how about giving explorers a free pass for a place? And that place is 50 kilometers radius around recognized places that can use hydrogen. So that essentially, all other things being equal, I heard somebody say that hydrogen was everywhere. Hopefully it is. That we incentivize people to explore for hydrogen close to where it can be consumed. And 50 kilometers was or 50 miles, take your pick, is a sort of distance that you could possibly pipe hydrogen to a point source, and that point source could be Fairbanks or Anchorage or the Red Dog mine or the fertilizer plant in Kenai or other essentially key existing demand points that could consume hydrogen effectively today. The Donlin gold mine could really use energy to cause its development. So our idea is give them a free pass, but maybe only in areas that directly benefit the state and that marries production with consumption. And if the DNR says, well, you know, giving people a royalty-free pass doesn't work for us, you go, well, if you give an explorer a free pass within 50 kilometers of the Donlin gold mine, you get your royalty through the gold, or the mineral that's mined at the mine, rather than the royalty through the hydrogen that supplied it. You get your royalty in the end, it's just in a different form. So that's our idea, trying to marry, because we got to get the explorers to come here, and if they find hydrogen in the middle of nowhere, they're not going to be very successful, nor are we. That's it.
Test, test.
Here we go. So we've been thinking about how some of that fundamental research that's still needed on geological hydrogen is going to be funded. And so traditionally our funding has come from mostly federal agencies. So NSF is where a lot of our funding comes from, also DOE, DOD, maybe potentially also ARPA-E in the future. And that funding is really needed to get started on geological hydrogen research. I think here in Alaska, we've got a pretty good research infrastructure at UAF, at the GI, at the Alaska Critical Minerals Collaborative. And there's a lot of people here who have expertise that they can contribute, and there's some good research infrastructure that's already in place. And in the past, we've been pretty good at attracting funding, at developing new ideas, and writing the proposals to actually get that funding. But for that, we need the funding opportunities in the first place. So I think that's the main thing that we need. As long as the funding opportunities are in place, I think there's lots of people here who would be interested and who have the expertise that they can contribute, and the proposals will come.
Thank you all for the input. I mean, it's great for our report and great for us to be brainstorming together across all this interdisciplinary and interagency, interorganizational boundaries. Barb?
That was recorded, by the way, and so we'll be able to get the transcript of all those great report outs. All right, just a few little items of business at the very end. We have Slido. Is this Slido up for the feedback? Okay, we have 3 short Slidos. You just have to input 3 little numbers, a feedback about the kind of information and collaboration and other things here. Again, when you leave, please pick up your tables and put your name tag in the box back there by Karsten. There are still forms and things back there you're free to take, and also a little bit more Halloween candy. And then just a little plug, I'd be happy to connect with anybody on LinkedIn. So please find me on LinkedIn. And now here's the thank you. There.
Barb wants to make sure I don't miss anyone, because everyone here contributed and we greatly appreciate it. I want to start with the funders for this workshop, and that's the U.S. Arctic Research Commission, University of Alaska Fairbanks, Office of the Vice Chancellor of Research and Geophysical Institute, and the Department of State Office of Arctic Affairs. Without that funding, this workshop wouldn't have happened. So we're very thankful for all that organizational support. We want to thank again, as we talked about, all the folks that worked on hard on making this happen, in terms of our steering committee, in terms of all the folks that worked on it. And if I could just get those to stand up, everyone who worked on this workshop could stand up, and I'd like to give them a round of applause. And I'd like all the speakers to stand up, and we can give them a round of applause. And all the moderators, stand up, please. And I'd like Barb to stand up. Thank you. And again, we want to leave this room open. If you guys want to keep talking and collaborating, that's great. We're still working on the form of the report from it, but we will put out a report and recommendations from the workshop. We're still, again, working through that format, and we hope you keep working together to making this happen, because it's been extremely valuable to us as organizers. But I hope everyone learned something. We'll have to see. Did everyone learn something? So far, so good. Oh, we have one person that didn't. Well, it looks like most of us learned something today, or this week. So I'm very happy with that. Thank you again. And again, you're welcome to keep talking and keep networking until about what time? 5 o'clock? 4:30. And thank you for attending.